Muito bom dia.
Good morning, ladies and gentlemen who are with us in the auditorium and those watching us online. My name is Felipe Bueno, and I would like to officially open the second day of the 5th International Seminar of Medical Devices organized by ABRAIDI and ANVISA, which is the main meeting on the regulation of medical devices in Brazil. Our event is being sponsored by Boston Scientific, Braile, Intuitive, Link, Medtronic, Orthofix, PNF Products and Features, Stryker, and Viman Systems. So let's get down to work. Just an important message for those of you using simultaneous translation in the auditorium. We have 3 languages available. For Portuguese, please select channel 2, Portuguese channel 4, and Spanish, please select channel 6. So our first panel will be discussing additive manufacturing and customized medical devices, concepts, regulatory challenges, technology, and safety. To moderate our discussion, I would like to call Katia Shimabukuro. She is the coordinator for implantable materials in orthopedics at the GGTPS department in ANVISA. Welcome. And now let's call the speakers of our first discussion panel. Clariana Gomes, Senior Manager for Regulatory Affairs and Quality at D-Link Brazil. Joining us online from Italy, we have Mr. Riccardo Toninato, who works as manager for the development of new products and processes for additive manufacture from Inovis Lima Implants. Good morning.
Everyone, you hear me well?
Hi. Também
Also joining us online, we have Matthew DePrima, who is a material scientist at the Health and Human Science Department from the FDA. Yes.
esse aqui.
Good morning.
Morning, Matthew. Morning, Ricardo. Good morning. Welcome. E ainda
And Mr. Rafael Trummer, a researcher at INMetro, the Brazilian Institute for Metrology and Standards. Good morning, everyone. Good morning. Good morning. It is a pleasure to be here with you today. This is our second and last day of our event. Once again, I would like to thank ABRAIDI and Dr. Sergio for inviting me to moderate this discussion. We're establishing a partnership in order to bring you interesting topics in the agenda. Sergio approached us in search for topics to be discussed, and we came to the conclusion that this is a very important topic considering the current landscape, additive manufacturing, and customized medical devices. So we will discuss some concepts, regulatory challenges, technology, and the safety of the customized medical devices. There are different types of technology that are used for the manufacturing of medical devices, and this is just one of them. And this panel is one that we have been waiting for so we can clarify some misconceptions that might exist about the topic. We have a lot of misconceptions in terms of terminology here in Brazil, and I'm very happy to have Matthew with us for the discussion. Thank you again, Matthew, for joining us. Because as a regulatory authority, sometimes he might faces some similar challenges and issues as the ones we are facing here in Brazil. So I think this sharing of experiences will be very important for all of us here. So, because we have 4 speakers for this session, Rafael will give his presentation in 15 minutes, and he'll be discussing 3D printing and the standards. After that, we will hear some concepts with Clariana. After Clariana, we will hear from Ricardo talking about the industry's perspective, and Matthew, who will be talking about some critical aspects of using 3D printing, benefits, and some more interesting topics. I would like to wish you all a great presentation, and I hope we can clarify many of the issues and answer your questions at the end. So, let's begin. Good morning, everyone. No. So I'd like to thank ABRAIDI for the invitation to speak at this panel. Thank you, Katia, for the invitation. In Metro and ANVISA are both government bodies, so we are quite close together. Okay, so I'm the problem. And it's always good to discuss these topics together so we can improve the country's knowledge on the matter. I'll be giving you an overview, some concepts, talk very quickly about the processes and the standardization. In the past few years, I have been participating in different international forums for the standardization of this topic. I will be passing around 2 samples that Fabio from Farco was kind enough to bring us, and they were manufactured through 3D printing, just so you have an idea of what we are talking about. This is a hip cup and a spine cage that were made in titanium. So we're talking about 3D printing, but I don't know how to use a clicker. So a little bit about myself. I'm a materials engineer. I did my master's and PhD in the Federal University of Rio Grande do Sul in Brazil. I'm a researcher at the National Institute of Metrology, Quality, and Technology in Brazil, which is called INMetro. Most of you might talk to INMetro when it comes to certification and compliance assessment, but we also have an area of scientific metrology. Later, I'll tell you more about what we do. And when I joined INMetro, we do wear essays in orthopedic prosthesis, and that's when I first got in touch with 3D printing because the closeness of national manufacturers have with InMetro. I think orthopedics were one of the first areas in Brazil to start using 3D printing. So as a materials engineer, I was really fascinated by the process, and I tried to learn more about it still in orthopedics. And since then, we have organized some activities to foster 3D printing in Brazil. Since I joined InMetro 15 years ago, I have been working in standardization bodies such as ABNT in Brazil, ISO, and ASTM. At ABNT, I coordinate the study commission for implant materials like stainless steel, titanium, and others. I also coordinate the commission of surgical instruments, mostly to analyze documentation. At ISO, I'm a deputy, which is different. In ISO, we're talking about countries, and ASTM, we talk about associations. I'm Rafael. I'm associated to ISU. I'm a deputy, and we have a vote as Brazil there. And I just wanted to highlight that I've been at ASTM for 10 years. I got a pin for that. That's the biggest prize I've ever gotten. It's a volunteer work that teaches a lot, so we do gain a lot of knowledge, and it's very good for networking as well. So I'm sure the Brazilians know about In Metro. This is our logo. Actually, yesterday, In Metro sent a guide to the whole staff on how to use this logo. As you can see in the corner of the slide, we have our motto, which translates to trust is our brand. So every time we talk about In Metro, we're talking about trust and quality, and we use different mechanisms to ensure that. Speaking of scientific metrology, and I'm a quality manager in our lab, we go through internal audits, creating perhaps an analogy with what Tiago mentioned yesterday about ANVISA. We do a peer assessment in our quality system. So we are constantly searching for evidence that we are in compliance with all the standards. Again, our goal at InMetro is to strengthen national companies. InMetro is under the structure of the Ministry of Development, Industry and Commerce in Brazil. So our focus is helping national companies improve their productivity with a focus on the safety and quality of their products. Our scope includes basically three areas. First, metrology and quality. Metrology is the science of measurements. We have traceability since the International Bureau of Weights and Measurements all the way to Brazil. So if someone is assessing a scale, they need to be connected with our traceability system. We also work on quality, and the government, working together with the Competitiveness National Secretary, launched a national strategy for quality infrastructure. We are one of the main stakeholders developing this infrastructure. And this year, we celebrated 150 years of the Meter Convention. Brazil is signatory to this convention. Metro is a technology and science institute here in Brazil, especially in the scientific metrology department. So we also do research. We offer a PhD courses and technical courses as well, and we work with technology development. For example, inside my department, the materials area, I think we are responsible for most of the papers in Metro have published. This is a picture of our installations. We are located in the state of Rio de Janeiro, in the city of Duque de Caxias. And we have a partnership with the municipality to train quality technicians locally. We have a partnership with a social institute in town. These buildings have our traceability, so acoustic, mechanic metrology, mass, the 1 kilo standard in Brazil comes from in Metro as well. So back in 2019, I first got to know 3D printing, and since then we have developed some initiatives focusing on what we do best, which is characterizing materials. We have a consortium for post-metallic materials. NIST in the United States launched this initiative, and we're part of this. And NIST, which is the metrology body in the US, they are our peers in the US. And the idea is to understand the metrics connected to the powder 3D printing process. This is a 5-year project. We started this year, if I'm not mistaken. And the idea is to brainstorm all the important factors that should be considered in 3D printing and how can we measure the powder and the different techniques. We also participate on the FINEP project, which is a network from Rio de Janeiro. It's led by INT here in Brazil in partnership with InMetro, INTO, the Federal University of Rio de Janeiro, and CBPF. INTO is a traumatology and orthopedics hospital, a reference in Brazil, and we received a maximum score in this call for proposals, which only proves the level of excellence all these institutes have. And the idea here is to establish a process in Brazil. It was we had a problem with his mic. Can you hear me now? And here the idea is to manufacture trabecular metallic metal cones for revision procedures for hips and knees. And we also have a scientific and technical cooperation with Farco Technology. And the idea is to share knowledge to promote metrology and 3D printing in Brazil. Fabio and I have been participating in different international forums, so we can exchange a lot of knowledge about these matters. Always thinking about advancing 3D printing in Brazil. So speaking of 3D printing right now, my idea is to give you a quick overview. I don't know how familiar you are with the process, so later I can pass the floor to Clariana, Matthew, and Ricardo. So it's an additive process. Conventional materials for orthopedics, they are subtractive. So I start with a bar and I use SCNC and I produce the final specimen, which leads to a lot of waste. Sometimes I start with a big bar to manufacture just a hip cup, and half of the material is wasted. So the 3D printing techniques allow me to use the material and build complex structures. And the big advantage is that we use 3D models to do that. Currently, we have scanners for doing reverse engineering. I have a specimen, I can scan it and develop a 3D model based on that. And throughout my presentation, I'll be mentioning some names. I've been part of this process for 15 years, and I think it's very important to have the technical standards. So every time I can, I will be mentioning the standards, sorry, not the names. So 3D printing or additive manufacturing is one component of orthopedics. Orthopedics is the broader part of 3D printing, but the same technique is used in the automotive industry, in oil and gas, the space industry. Petrobras, for example, in Brazil, has been investing in 3D printing for many years. Currently, there's a RFP from Petrobras in Metro is participating because, again, we don't work only in the medical area. We'll be participating with other institutes in this RFP. And it's great to be part of these forums because sometimes challenges in the oil and gas industry might be similar to the ones we face in medical. Because at Petrobras, they have a large inventory of parts. Because imagining an oil rig stopping production because an issue with a valve, that leads to financial consequences. In orthopedics, of course, we're talking about lives. But they need to have spare parts. They might never be used, but they need to have that. So the idea is for them to develop a digital repository. Whenever there's an issue with a spare part, they will print it and take it to the oil rig. But what about the confidence or the reliability of that part? I will print it just once, so we need to ensure that it will work. And again, one advantage of the additive manufacturing process is being able to build parts from scratch. The one in the middle is a spine cage, but the technique has already been used in civil construction. Houses are being 3D printed. This is one example that we see in the up right-hand corner. We bought this online, actually, this printer, and I printed that Batman figure. I was in a mall, and there was a guy with a 3D printer printing uh, figurines like this. We can also print surgical guides, like in dentistry, 3D models to help the surgeons with the surgical plan, and orthopedic implants that have unique characteristics.
Here, advantages, pros and cons. A pro, uh, it's allowing enabling innovation, free project, and widening of product offer. So I can do everything in a digital file. In orthopedics, I can eliminate the use of cement. Many doctors are using fixation without cement, and a con, it's not in fact a con, but the company has to understand why they are implanting additive manufacturing. The real value, the benefits that we get, it's not because it's cool, and it's Ian now that I'm going to do that. Two different trabecular structures. Dr. Link showed yesterday that coatings in manufacturing we can do in one step only. A structure that allows also integration, and you could see the size of the equipment. Some concepts, manufacturing plan. So the manufacturer establishes the production sequencing, the additive system parameters, and manufacturing control system. Another thing is the post-manufacturing process. There's a terminology involved here. What I'm going to do after removing the part from the construction chamber. I will talk about that. As I told you, in Metro is focused in post-metallic part, metrology and materials division. We've been working a lot with pounder characterization, also in the consortium with NIST. And the used pounder, what is that? It means the one that was food material, but at a certain point in time, it was exposed to laser beam or electrons beam inside the machine. And we have virgin pounder in a lot, in a batch that would be retrofitting. That was never in the retrofitting chamber. The pounder is the powder batch I purchased from a supplier, produced under traceable, controlled process in a single cycle of process. The powder mixing is really interesting. A titanium one is not cheap. I need to reuse. In manufacturing, we have this advantage. I can put a powder in a machine and I can reuse it, but it's not as simple as it seems. I need to characterize it, this mix, and I need to have an idea if the same initial characteristics will remain, if I can reuse it again and turn the process cheaper. These are some process categories. I'm not talking about all of them because I'm know more about the pounder technique, but there are many, the 7 nights, as Fabio used to say, maybe here D&D, direct energy deposition, using oil and gas a lot, and you can produce large volumes pieces, parts with that. One of the processes which are widely used in orthopedics for implant parts is power bed fusion. There are two techniques, laser and electrons, because I have a pounder bed, the metal pounder like a bed, and a source of power of energy will melt it. I can have laser electrons. Electrons is like a super MAV. I have a cannon of electrons. It will hit the powder bed and will melt my material, will forge it. The atmosphere difference also, one is atmosphere, the other vacuum, and the fitting material will be different. It have different characteristics. To the right, I have a graph to show you. Maybe Matthew will talk about this later, showing that pounder bed fusion is the most used in US for producing parts in titanium and also laser. It's nice to talk about post-manufacturing processing because it's not ready out of the machine, so we can do post-processing. Removing the powder is a critical thing to me. We can do finishing, a superficial one. Sometimes we need to do when we can do piercings, giving a new finishing, machining process, like they call it, hybrid process. Some points of the process itself that I think are critical ones. It has to do with the manufacturing plan. But these are critical points. I think the 3D, digital 3D file, the raw material in pounder, spherical pounder, and another thing is anisotropy. I can manufacture the part in the chamber in many orientations. This is what we call additive manufacturing design. They could be in a different setting, inclined, standing up. The support is also critical. We need to remove them. They are used for supporting the part as it's manufactured. They can also dissipate heat. And a critical point also is the residual powder. The one that was not used, we need to remove it from the part somehow.
Falando um pouco. É melhor esperar?
Acho que vamos.
Sorry, we're having technical issues. We're just changing the microphone. Coming back. Now about the raw material, we have different compositions. The chemical part, oxygen is critical because it affects the performance of the part. It's not only the chemical composition, fluidity, morphology. You saw they are spheres. It's really important to take into account this in the additive manufacturing. And to close, I will talk about standardization. I've been working with ISO for 15 years. The first one I was part was in 2019. I met Fabio back there. We exchanged a lot of ideas on standardization. And there's a nice thing about that, which is additive manufacturing, a recent process. It's been growing quickly. And ISO and STM understood they cannot be barriers. So they decided to act together in additive manufacturing area. They have an agreement. They establish standards together. ISO is an international body, and ASTM an organization. So additive manufacturing is there. At STM, they have a F42 committee about additive manufacturing, many subcommittees as well. 42.07 of applications where we have medical sector in that. And I would highlight 3 documents in ASTM dedicated to implants. They approach the powder reuse, validation of the additive manufacturing process for medical devices, and non-destructive salt and assessment methods as well. I intentionally put this slide like that. It's not for you to read, but it's just for you to know there is a normative database, and these documents are support for regulatory part. If I'm doing additive manufacturing, what do I have to know about that? We have there the documents. There are many discussions to create documents and critical points in additive manufacturing. TC 150 about implants for surgery. This is the one I'm acting in since 2010. It's not left behind. Additive manufacturing is being used for the manufacturing of implants. So we understand. You understand about additive manufacturing, us about implants. So there's the document, the FD is the last one. The document is ready and it approaches some critical points of the process. As the scope is telling, it identifies factors that affect the safety and the performance of surgical implants. Also in Brazil, CE 261 and CB 26, ABNT 16627, a lot of documents about additive manufacturing. And I would like to, the takeaway message, we have a base, a solid base, normative base to be used. When necessary, we can reveal or cancel them. The process is getting more competitive, reducing costs, speed of printing, or new materials. The big thing we have to discuss is how to assay, measure, customized implant. But there are modeling we can do. There's the digital twin matter when we can monitor the process in real time and we can build a model out of that. Also, how to assay structures with trabecular structures We are used to that in compression. And the goal is, since we're not able to make an essay for this part, we can know it's knowing better the process. Robust, reliable process. And there's also another standard, 36 for dealing with the assessment of medical devices manufacturing process. Thank you. Thank you for your attention. It was a pleasure to be here.
Agora a Clariana vai.
Clariana is making her presentation now.
Estão me ouvindo? Beleza.
Can you hear me? Great. So, we talked a lot about additive manufacturing, new technology, but it's not as new as you think. And we are here to communicate on how is the application of additive manufacturing along with customized prostheses, mainly specific and customized patients.
Então, rapidinho, quem sou eu?
So, most of you know about me, but I'm working for 15 years in regulatory matters. I'm a senior director of Link in Brazil, subsidiary of Valdemar Link. I'm a PAHO consultant along with ANVISA with cosmetics and sanitation. I'm working with a lot of things. I'm also an auditor, quality auditor, ISO auditor, and in love with regulatory matters because when we are here, we really need to like regulation, regulatory improvements, and so on. So we start with some questions. What is the application of additive manufacturing? What is a customized medical device? What it has to do, additive manufacturing has to do with customized medical device. Is there a difference in concept here in Brazil and globally? During my presentation, we're going to find out a little bit about that. It's important to start telling you that additive manufacturing is really important. There are a lot of advantages, but it's not the only way of manufacturing customized products for specific patients or customized ones. There are traditional ways like machining, casting, forging. We know them for a while now. So additive manufacturing can and should be used in specific cases. It's not that from now on we're only using this one. No, there are parts of implants that must be made by these kind of manufacturing because they should have the solid part. For example, in a femur compound, it needs to be polished, it needs to be solid, so makes the knee articulation joint easier to move. So additive manufacturing is great, many advantages. We are using each time more, but it's not the only way because many times we relate additive manufacturing with customized product as the only manufacturing way, but it's not. Rafael mentioned about this technical part, but besides that, I will also talk about the clinical part. We have numerous advantages of using additive manufacturing, the reduction of the development time, flexibility in production, possibility of producing with reduced stock because I can do it quicker, many technological advantages, but there are also facilities and improvements, clinical improvements as well. Patient application where we can use additive manufacturing, for example, in customized medical devices. We can say that we have a superior integration, faster osseointegration. We have possibility of anatomic customization, our theme here, what the patient's needs in their anatomy. We can make a 3D design with additive manufacturing, lower risk of infection. Mr. Link told you yesterday about that, about nanoparticles, the possibility of integration with proteins, so lower possibility of infection, higher distribution of cargo and release, lower chance of release. So additive manufacturing is a method that's being employed a lot in medical, customized medical devices, but it's not the only way. We have some scientific data for you on how additive manufacturing is used. We have many papers approaching the improvement of osseointegration by porous geometry through additive manufacturing, then also integration made in solid titanium, for example. This is widely known. It's advocated by many. And we have an image, I think is this one, on the osteointegration process with 3D implanting, 3D printed implant, because the osteoblast has more integrity with this porous structure. That's why it's faster. Mr. Link approached that yesterday in more details. Here, we're talking about the customized prosthesis or customized medical device. This image is, we have many of them. You got in touch with them today. The customized medical device, the one we have in the picture, we should know better the difference on specific patient and customized. These there are differences. This is the gap of knowledge we see in companies and among people that act in this sector, making a confusion on these concepts. A little bit about the history of Link. Mr. Link was here yesterday, but this is the factory where I work in Brazil. It's there for more than 75 years, and it's working with medical device, custom-made medical device for more than 50 years now. But isn't additive manufacturing a new technique? But as I told you, there is the customization through other manufacturing methods. So at that time, there was forging, casting for custom-made prostheses for patients all over the world. And then, as a factory, we have more than 50 years of experience, a success case from the beginning. We have many others, but in the beginning, in 1978, we were able to implant a custom-made prosthesis in a patient that's held it for 35 years without necessity of revision, showing customization was well applied and provided a life quality for that patient, which is the goal when we are doing a customization.
And this might seem like a lot. We have done 35,000 cases, but we're talking about 35,000 custom-made products that were either patient-specific or custom-made, which have slightly different concepts that I will explain. Oh, I will now show you a video on our manufacturing process.
Online portal streamlines the process from pre to post-op. After a simple CT or X-ray upload, our specialized 3D modeling software begins mapping the patient's anatomy. From here, our in-house engineering team creates a bespoke design incorporating proven technologies. You can be involved as little or as much as you want with direct communication to the engineer through video and chat conferencing. Once you approve the proposal, we begin manufacturing at our state-of-the-art facility in Germany. Even the most complex implant designs are realized by us using the latest in 3D additive manufacturing.
Manufatura aditiva que o Rafael estava
Implants are
falando.
cleaned, sterilized, and shipped in sterile packaging together with a matching surgical technique to your hospital. Link has a comprehensive portfolio of successful standard primary, revision, and tumor implant systems. Many of their proven technologies are incorporated into custom Link implants. Like Trabeculink, surface structure for secondary fixation and bone ingrowth. Thanks to our in-house engineering and manufacturing, Custom Link has delivered life-changing solutions to more than 35,000 patients for 3 generations. Every custom implant is delivered in 4 weeks or less.
Então, aí,
So you were able to see the customization process and how important it is and how fast it is. Because again, patients, they need a customized piece, whether if they are just custom made or patient specific, there is an urgency. So Valdemar Link has a process that from project until the surgeon receives the specimen, it takes a maximum of 30 days, 4 weeks or less. And this is the whole process. You have the CT scan, which is the medical imaging exam that is sent to us, and the physician is always involved for custom-made pieces. They are in charge of the process. Later, we'll give you the details of Brazilian standards and international standards, and later it will become quite clear how important it is to have surgeons involved in the process. So, just so we understand why it is important to have a customized products and how was the ANVISA approach in dealing with these devices over the years. I'll say that before 2019, and I was already involved in this, every time we needed a customized prosthesis, we would send letters to ANVISA, a documentation. Karen, who is the manager, she was part of this process. So every time we needed to do a case, we need a manual approval process for the customized devices. And the process was a little bit slow. We didn't have a lot of details on how to approach this. Each company would share information they deemed to be important, both in the medical report and the letter. So Anvisa and the market saw the need for improving this process. And then in 2019, we had the publication of standard or RDC 305. Because again, as I often say, it's very sad when we don't have a standard to use or follow. Every time we have a standard, we can discuss improvements, of course, but to make someone working in regulatory affairs happy is give them a standard. So in 2019, we had the publication of standard RDC 305 from Anvisa. But Anvisa, at the same time, understood that the market was not ready for this. So even though the standard was developed in 2019, Carlos, my manager, and I, we went in different meetings with Anvisa to try to bring advancements in this area. We need to do this is right, this is not. So we would take our cases to them, and Anvisa was sensitive enough to create a transition period, a period to allow companies to understand the standards and adapt to them. So we had some level of flexibility for a while until everyone could have full understanding and alignment. And then in 2023, that was our deadline. and that's when the standard became fully valid. In 2024, we also had another standard, RDC 925, which is the current standard, but it's part of the changes that we had in that year. But the basic concept remains the same. These are concepts that are aligned with IMDRF. ANVISA and IMDRF, are really close. So the standardization is always done with a lot of transparency, working together with IMDRF. So ANVISA is fully aware of the need for a regulatory convergence, something that we working in regulatory affairs are constantly looking for. So the standard that we use today is RDC 925. I need rules on customized medical devices. So this is just a summary. I think I've mentioned most of this already, but it just illustrates the scenario before the standard, RDC 305, and the reality today with RDC 925. So before the standard, the clinical documentation was sort of generic. The notification process, so every time I was going to import a specimen or manufacture this, the notification was mandatory, but we didn't have much of a standard to follow. Now everything is standardized. And now we're about to get controversial. And this is actually one of the main slides that I want you to take with you, which is the difference in concepts when it comes to customized medical devices established by the Brazilian standard RDC 925. This is in a table just to make it very clear to all of you. I didn't write this in a text because I thought it might be confusing. So here I bring a comparison. We're going to start from the simpler component. A customized medical device that is adaptable. In this case, the surgeon has an instrument that is used during the implant, and they adapt the specimen according to the patient's anatomy. In more than 90% of the cases, we're talking about buccomaxillary prosthesis used by dentists. So they have an instrument and they change the angle of the device depending on the jaw of the patient the moment they are actually doing the implant. This is an easier concept to grasp because every time you have a need for adaptation with the use of an instrument, we understand that this is an adaptable medical device, customized medical device. The registration here is regular based on RDC 751 from 2022, and it is important to understand that this possibility of making an adaptation needs to be quite explicit in the documentation. You also need to list the instruments that can be used, the maximum angle that can be achieved, but it is still a simpler concept. Now, the difference between a patient-specific medical device and a custom-made medical device, this can be a little bit confusing. So I'm trying to solve these questions right now with you. First, a patient-specific device and a custom-made device, both of them are based on the patient's anatomy. So there are a couple of myths here. It is a myth that a patient-specific device is not done based on the patient's anatomy. Or because the product is being made based on the patient's anatomy, is going to be custom-made. No, I can make a customized product based on the patient's anatomy and have a patient-specific product, not a custom-made product. I'm going to show you later that custom-made devices are the exception. So what is the difference? What are the differences between a patient-specific device and a custom-made device? Overall, there are two main differences. First, a patient-specific device is based on an existing design from the manufacturers. So we have an accountability, and the engineering team is responsible for the design. Now, a custom-made medical device is also based on the patient's anatomy, but here the main responsibility is on the surgeons. Of course, the manufacturer is also involved, but the main responsibility is on the surgeon side, and it is not based on an existing design. So in summary, a custom-made medical device, the manufacturing is done only once for that patient. I will never have a second patient receiving exactly the same device. It's exclusive to that patient because it takes into account the bone loss from that one patient. Now, a patient-specific device, I can do a batch manufacturing because I have a range. A diameter of the stem, for example, that can vary from 10 to 60, and that range comes from my original design. So, because a patient-specific product can be manufactured in batches, I can even keep it in stock. One great example to give you is this one. Whenever I have a knee prosthesis, I have a case, for example, of a patient who is a basketball player from the NBA. Their leg is probably going to be longer, so they will need something that's quite specific to them. But it doesn't mean that we will never have another basketball player with a similar need. It is a possibility. So usually, depending on the case, of course, most of these products are actually patient-specific devices. But I'm going to share some real cases just so you memorize this. Now, okay, this is about ANVISA. What about internationally? How does this work? Well, ANVISA is aligned with IMDRF, so the concepts are pretty much the same with some small differences. But here in this table, we have the nomenclature. In Brazil, we call it customized medical devices. In Europe, they are defined as custom-made devices, and in the US, custom device. And on the right-hand side, we see the main standards and legislation on that matter. And it's interesting to realize that, for example, in the FDA, the name of the standard is Custom Device Exemption. And in the name of the standard, you can see that this is an exemption. This is not a recurrent type of product. So the concepts are pretty much the same. All of them cover the fact that this is a product that's based on the patient's anatomy, prescribed by a surgeon. And in the US, they add one detail, which is the limitation of marketing or the limitation of the production capacity. So again, in the US, it's very interesting to see that besides including the concepts that are used both here in Brazil and in the Europe, there is a quantitative limitation that later I will explain more. And it's great for you to read the slides later because I'm not going to read everything to you because we don't have a lot of time. But it's interesting to see here the dossiers, the documentation. For the three regions here, they require a medical report based on an imaging test. The surgeon must be actively involved in this process. We're talking about, again, customized devices here. And for example, in the US, here in Brazil, what happens in summary? We have two steps in order to make a customized device because the patient-specific device and an adaptable medical device is regulated by a different standard. We can import them just like we do for any off-the-shelf products. But a customized medical device goes through steps of regularization here in Brazil. First, we have to ask ANVISA to certify the plant if it's able of producing a customized device. And that is dependable on the plant manufacture or having manufactured off-the-shelf products that are similar to the one we plan on producing. In the European Union, and the second step in Brazil is the notification. So every customized product that is manufactured and it's going to be imported, we need to notify ANVISA that that product is being produced, and I need to present all the technical information, a bunch of reports, and a lot of information. And one important step in the documentation process is the post-implant control. The traceability of the product is much more detailed than the traceability that exists for an off-the-shelf product. In the label, you have the name of the surgeon, the name of the patient, highlighting how specific that product is. So as the the person who is responsible for the technical aspects in the company, I prefer, of course, to use an off-the-shelf product because we share the responsibility with ANVISA than using a customized device. Because in this case, the surgeon, the plant, and myself need to control all the way after the implant is made. So we need to be very careful when we approve these cases or before we begin the manufacturing. One important thing that I highlighted here, maybe Matthew can tell us more about this later, is the limit or the legal limit of a maximum of 5 custom devices, a maximum of 5 custom-made devices a year. Why 5, not 6? There is a technical rationale for this, for establishing this limit of 5 custom-made devices a year per company, and I think later we can learn more about this. So these are some real examples. We are very visual as human beings. So this is an example of an adaptable medical device, usually used by dentists. This is a patient-specific device, and this is great. So a patient-specific device, we only have changes in the dimensions of a product that was designed by us. So on the left, we have an off-the-shelf product with a 6-degree angle, and the patient-specific required a 14-degree angle. The rest of the design is the same. The only difference is in the angle of the stem. This is a patient-specific device. It's not a custom-made device. This is another case. Also a femoral stem. And there was a need to increase the diameter. Only a change in size. But the basic design is the same. It hasn't been changed. We only changed the diameter of the femoral stem. So this is a patient-specific device. Oh, but it was done based on the patient's anatomy. Fine, but it's still a patient-specific device.
The custom device here. You can see clearly the custom device here. This is a case that you can clearly see that is a specific bone loss and a need for that patient. Something complex, complicated. Nothing else would solve that problem. Another case of custom device. This is a acetabular pelvic part. A loss, a big bone loss. Just to close, some numbers. The ANVISA's data we have here, the number of patients custom device notifications per year at ANVISA from 2022 to 24, around 750 patients a year with their solutions. And we ask, is this a lot or not enough? It seems a lot, right? But it's not. When we see the number and we have a comparison and a detail, why there was a peak in 2023 when the standard is passing the transition time period ends, then we put a lot of dossiers, we bring a lot of dossiers to ANVISA. This was the cutting date, 2023. That's why the custom device dossier increased in 2024. ANVISA started to apply a strict standard, then they cut a lot of wrong dossier. They just add to everything. So this shows a little bit how we're just going for it. Why 750 products per year custom device is not enough? Because Karin showed yesterday, there's an Anvisa has approval of medical device in general of almost 8,000 devices a year. So 750 is less than 10%. And the trend is to reduce this data. Now with webinars and knowledge, for sure, this number will decrease to cases there are strictly, in fact, custom-made, and we're just differentiating specific, patient-specific that is inside this number as well. And to close, less than 10% of petitions for new products are custom devices, and the number is about to be reduced. So we're working for only adding the necessary cases. Besides the surgeon, the manufacturer is also important. The regulatory sector in Brazil knowing deeply and help the factory to understand the Brazilian standard, differentiating specific patient from custom-made product, and solutions must be proposed gradually. First, shelf product, then patient-specific, and last case, custom devices. So custom device, customized prosthesis is an exception. Last slides. So current challenges of customized medical device. Ambiguous interpretation of key concepts, as we mentioned. Technical training of small companies. They don't have a lot of funding to work with training. Adequation and impact costs in prices to the end consumer. I'm not from commercial area, but we understand that custom devices, they have a higher value than shelf products because it must be limited, because the idea is given conditions to the patient so they have the technology available to them. So this is a gray area when we talk about custom device costs. So we need to work for the company within a maximum range. We can also serve the patient's needs. The insurance can pay for that, and also the public health system being able to pay for that when it's necessary. Continuous training of sanitary surveillance, the local ones, and to close, I'm always talking about next steps, suggestions, in fact. Continuous open of the dialogue with ANVISA. We always talk to them a lot. Performance of webinars. Karin has worked a lot in that matter. Every time we ask for a webinar, they do everything for us so we can do it online. And our request right now is the elaboration of custom devices regularization manual, because now it's a manual, many activities, a manual, and now another one, but we need to try for the things we want, right? So elaboration of a manual and periodical update of the standards with our inputs, the contact we always have with them. Thank God they are really open to this communication channel with us. So thank you, everyone. Thank you, Clariana. I think it was you. You brought us a lot of clarifications. Clariana bringing clarifications. Now we'll have a presentation from Ricardo. Ricardo, can you hear us?
Can you hear me?
Ricardo Toninato.
Ricardo Tominato from Enovis. Good morning.
Good morning, everyone. Can you hear me well?
Yes.
Okay, super. So, thanks, Katia, for the introduction, and good morning, everyone. I'm Riccardo Toninato from Enovis Corporation. It's definitely a pleasure to be here today with you, even if I'm connected from remote. Actually, I'm from Italy, where I'm based, and my presentation focuses on our experience with additive manufacturing from a broad perspective, let's say. And so just one word on me. I'm an R&D guy. I had a biomedical engineering PhD back in the days. I joined a company called Lima in 2016 as additive manufacturing responsible for new product development. And after the acquisition of Lima by Enovis Corporation, I'm now leading the global additive NPI, new product introduction team, dealing with different technologies, for example, electron beam, laser, and laser sintering. And I'm a member of the STMF 42 committee. So I just want to share with you a couple of highlights regarding Enovis and its additive manufacturing capabilities as a main focus of today, of this seminar, right? So Enovis is a medical technology company, and it's composed by different assets and different, I would say, sources. Historically, began with Colfax in the 90s. It, I would say, developed along the way through a medical company in 2010, basically, with the acquisition of DJO. And in 2024, after changing the name to Enovis, there's been the acquisition of Lima Corporate, that was founded in 1945 in Italy, and was a global orthopedic company focused both on, I would say, off-the-shelf and customized solution. And I'm part, of course, of the, I would say, this heritage. As I said, joined Lima in 2016, and now being part of Enovis, that is a quite big company with more than 8,000 people and with more than 30 facilities worldwide. Has been, I would say, a very great journey since the acquisition of Lima. But just to let you know where my speech today is focused and where I would say I belong in Enovis in the repair surgical implant division. So Enovis is ranging from prevention to repair to recovery. I'm part of the surgical implant repair team in the global team. And just to give you an idea of the additive manufacturing assets that we have, most of them are based in Italy. So we have an important facility for mass production in the south of Italy with a quite large fleet of machines, mainly powder bed. And we have also machines in the north of Italy, where I am based, and where historically the research and development department of Lima was based. As well, we have, I would say, a small facility in New York. It's a point of care within the Hospital for Special Surgery in Upper East Side. From, I would say, an historical perspective, to give you an idea, we started working with additive manufacturing and 3D printing in 2005 with the first generation, really the first generation of E-beam. And you can see here in the slide the evolution a little bit of this technology and how we step by step embraced the different, I would say, models with those, of course, the different things that come along with technological improvement and change. So our fleet is now composed of different decades of machines that since 2007, we will say, have been able to deploy in the market an important number of implants. And here I'm talking, of course, about off-the-shelf implants. And since I would say at the beginning, you can see in the graph with the red bars, the increment basically almost year by year of the amount of components that we implanted in the market. And of course, we are very proud that this is a constant growing where from strategical, I would say, perspective, we always invested in this technology in a vertical way. So having from R&D to mass production, the capability and the knowledge developed inside the company. And so let me speak a little bit about what is our experience, not only with the technology, but also with the products that we developed along these years. And this is really a snapshot of the products made by additive manufacturing that we developed in the past 20 years, basically. And of course, they are not present in all the markets, in all the countries worldwide. Some of them are present in Europe, some of them in Europe, US, or vice versa, some of them in Brazil, or Australia, New Zealand. So here there is really like a big overview, but you can clearly see also the evolution, in my opinion, of how we develop the products. We started back in 2007 with the development and commercialization of hip cap that transversally to the industry was probably the first exercise, okay? And then the transition for us was from hip to shoulder and to application of shoulder that, as you can see in the lower part of the slide, basically from 2014, where coupling the additive capabilities with quite, I would say, small implants, dimensionally perspective, compared maybe to a hip cap. In 2015, we basically formalized the birth of our custom division, even if some custom mates were developed also before that time, but not as a formal business unit that we call ProMade. And after that, basically, we had a diversification of application along the way, where you can also see the complexity that is growing. You can see, for example, an elbow off-the-shelf implant that implies, a lot of different thoughts compared to other implants, or a shoulder stem. as you can see in the right lower part of the slide, or for example, the knee tibial plate that we released in 2021. It's called Physica TT tibial plate, that you can, I think, appreciate, the variety of the applications and the evolution along the way. That, of course, is coupled with the experience from design perspective, interaction with the surgeons and with key opinion leaders in the sector, but also on the knowledge and development of the technology and our experience with the technology, in particular the additive technology, right? And I would say our mindset is to develop product and processes through applied research, aiming for a very high quality and the best process outcome, right? So we normally deal with machine manufacturers in order to challenge them as much as we can. We try to collaborate with the academias and research centers and to internalize the technologies, because we see the value of, I would say, developing inside this asset. And as well, I think that is important to remark how in the normative scenario is important, to contribute to have I would say, STM, eyes, or whatever, but a framework where the additive manufacturing capabilities, technologies, and material are understood and are developed in a way that is sustainable for the industry and can help at the end everyone. Let me now just move a little bit, staying on the product side, talking a little bit about advantages, challenges, development time, and cost. And when I was preparing these slides, looking at these words, suddenly come up in my mind as CDC, because I like them a lot. And a very famous song from ACDC is Highway to Hell. And I thought, right, is additive this? I think no, to be honest. And especially if you know how to make, when to make the right turns, how to, study the process, how to apply it, of course, in a broad team, from machining to quality and whatever. And I want to bring today a couple of examples, very fast, because of course of time's sake, but two different examples, very, I would say, different from the application perspective. One is the tibial plate that I showed you before. The aim of the development of this tibial plate was to develop a primary cementless tibial plate. And at that time, we were looking to an uncemented solution with high fixation rate and maximization of the load distribution, and with the possibility to have a very conserving revision approach from a bone perspective. And putting together all these tests, different research from the medical and the surgeons that work with us, we come up with a candidate design that you can see on the left side in the low part of the slide. But we were, working on also, of course, on the strength and coupling everything with the fatigue performances. And so we did a design optimization that been able to, through our iterations, right, to develop a final design that was able to take care, of the stresses in the right way, but also to maximize the amount of lattice structure for an optimal bone growth. And really, this was an important and not easy exercise. And at the end, when you conclude a project and you are able to register this implant in the market, then you look back, what you did, and actually what I can say from achievements in this case for this application, that I think that the application of design optimization can, of course, in the right way, can save, of course, time, can efficiently save time. We have been able to, reach a very high fixation rate with that, with a really non-invasive implant, easy to revise. And through the project development phases that, of course, took years, we are talking about years of development, we've been able to reduce like 1/3 the machining and finishing time compared to where we started. Of course, keeping the appropriate fatigue strength for the implant as well. And this is, in my opinion, really an example of how a company can work in a very complex application for mass production, having all the important assets, technological assets within the company, I truly believe that was, and it is one of our main, force here. And now I skip to a different example. A different example, staining the knee, but this one is an example that for a product we call revision cone. And the revision cones are really shaped like a cone that you insert in revision cases, but from a complexity of, I would say, the implant per se, they have a different, I would say, range compared to the tibial plate for different reasons. I don't want to stay on the details, of course, but also here, we saw the additive manufacturing as an important asset to leverage, an anatomical design, to have a high elasticity, to reach low thicknesses, but preserving the shape that we were aiming of, and of course reaching high adhesion performances with bone cement in the internal side of the component, but as well osseointegration on the lattice, And here you have some images of the shelf cone, but again, after we concluded the project, looking back, we saw how we have been able to reach a nice result, taking, for example, out machining in this case, because we reached the quality that we needed without having machining, so without having this kind of post-processing, this kind of phase. We've been able to fill free patents around this, I would say, very nice looking implant. And through process optimization and so, we saved 50% of the limb time, for example, on support, design and removal, support of the part, because the part are made also with support, mechanically, I would say, attached to the part from the beam melting. and also an homogeneous surface quality that is also quite important also in our sector. So just let me conclude. It's not always, of course, an easy road. The additive manufacturing development of products in the orthopedic sector. And there are still open and challenging questions also from our side. One, of course, is still the machine reliability. I mean, we always challenge, the process and everything around. So for us, we always want more. That's my point. And we put in place everything. It's important to make sure, to have robust, reliable, and controlled processes. As well, we are leveraging process simulation more than in the past because the technology definitely reached a different stage, as well as there are in situ process control solutions now that are coming up. A point is definitely the cost. Additive manufacturing is normally not a cheap process. And there is a lot of work that we are doing. And I think that also in the scientific community is emerging on additive related to the prediction of the intimate material performances of the material. And all of these, for example, all of these points, all of these consideration are, for example, part of many scientific discussion. And I want just to conclude and thank you all, saying that if you are interested in industrial additive manufacturing and research, soon also there will be an interesting, great, I would say, conference in Las Vegas that is the ICAM. It's at the beginning of October. I think it would be nice if you are interested to jump there and see really, I would say, different sectors, different presentation, but all related to additive manufacturing. And with that, thank you very much for your attention. I hope that was quite clear, also from my, I would say, not mother tongue English. And thank you.
Thank you. Thank you, Ricardo Toninato, for the presentation. And now we have the last, but not a última apresentação.
So now I would like to call our last speaker from Matthew DePrima from FDA.
I want to thank Fabio for putting me in contact with this amazing group. So, as mentioned, I'm Dr. Matthew DePrima. I'm with the U.S. Food and Drug Administration in the Center for Devices and Radiological Health, Office of Science and Engineering Laboratories, Division of Applied Mechanics. I just want to make sure, are my slides advancing for you?
They're working.
Yes.
Great. All right. So, since I do work for the U.S. federal government, I do have a disclaimer. Any mention of commercial products or sources or their use in connection with this talk are not to be construed as either an actual or implied endorsement by the Department of Health and Human Services. All right, a very brief outline of this presentation. I'm going to briefly touch on my background. I'm going to talk about the FDA and additively manufactured medical devices. We'll see at least one of the figures again. Then I'm going to touch on FDA's sort of perspective and the laws around personalized versus custom medical devices. I did mention I'm on the lab side. So we have a panorama of our main AM lab. We have a range of material extrusion, vat photopolymerization systems, and material jetting and powder bed fusion system. We do have a number of bioprinters as well as printers optimized for pill printing and drug production. Those are going to be in bio labs. All right, so briefly, my background, it's going to look pretty similar to a few of the other speakers. I'm a material scientist, a bachelor's degree from Rice University in Houston, PhD in material science from Georgia Tech. I've been at the U.S. Food and Drug Administration for almost 15 years now. I've been, I think, really lucky to be on the regulatory science side for almost my entire career. I did spend 6 months as a device reviewer. I've mostly been focusing on additive manufacturing and corrosion, two things that don't really go together, but when you're a material scientist, you go where the materials needs are. I'm the head of the additive manufacturing working group for the center, and I was the previous chair of an agency-wide working group on advanced manufacturing technologies. I split my time between doing research to support the regulatory mission, as well as providing direct regulatory support. So when there's an additive manufacturing question or complicated test reports in a submission, a lead reviewer will send it to me. I will review it, write up the questions, and then engage with the company if needed to get those addressed. In this role, I've been the main point of contact for 2 FDA guidances. The first and most relevant to this group is the technical considerations for additive manufactured medical devices. And I was also the lead on a technical considerations for devices containing nitinol. For standards, I'm the FDA liaison to ASTM F0412, which is the medical metals group. I'm also the FDA liaison to ASTM F42, which has been mentioned before. And I also co-chair ASTM F420703, which is the subcommittee focused on medical applications. So a quick sort of snapshot of CDRH, and I need to add the caveat that these numbers were from the beginning of the year. There's certainly been some changes, especially around number of employees. But more importantly, we regulate in a given year about 22,000 medical device manufacturers, just over 250,000 medical devices, and deal with about, again, another 22,000 medical device pre-market submissions. These will be a range of 510Ks, Q subs, PMAs, supplements, amendments. My specific group, we are the research labs. We're essentially sort of a mini university lab. We had about 180 people. We engage in about 2,500 pre-market consults a year. Again, that's when during the submission process, there'll be a technical problem that requires a specific expertise. We are engaged in about 125 research projects and publish and give about 450 presentations or so a year. All right, so that's really quick snapshot of the FDA and the research group. Let's talk about FDA and additively manufactured medical devices. So you've seen this first figure before. I do apologize for the sort of what we call the eye chart for this, but it's a great way to convey a lot of information. So while powder bed fusion makes up just over 2/3 of the AM technologies used in the products we've cleared, we do see every technology except the sheet lamination. DED was too small when we ran the analysis here to call it out specifically, but we do see it. We also have a number of software products for some application areas. And then for dental, we do have some clearances of just the resin. So far, those would all be for VAT photopolymerization. When we look at materials, again, titanium, very dominant. Next few slides will sort of explain why that is. However, we see a range of polymers, both nylons, PEEKs, as well as photopolymers, some stainless steel, a little bit of cobalt chrome. And then we have a sort of a pretty big other category. We see a whole range of degradable materials. We have a few AM ceramics. So that's why we have sort of a large other category. When we look to the types of devices, we see that spine cages or those vertebral fusion devices make up a predominant number. As a result of that, when we look at how many are patient-specific, only about a quarter of the cleared devices from 2016 to 2020 were patient-specific. Most of the intervertebral body devices, sorry, the lights just turned off. There we go. Don't need to be patient-specific. So there's a reason why we see so many of these cleared AM devices that aren't necessarily patient-specific. That being said, full range of orthopedic applications, some dental. At FDA, the maxillofacial are actually regulated through our neuro group. But again, while we see a few cardio applications, most of what we're seeing really are sort of bone interfacing products. If we look at some trends over the decade, from about 2010 to 2016, we cleared about 80 products. Then from 2016 to well, actually, I should say in total, we then saw 350 plus cleared devices. So the adoption of the technology by industry is certainly increasing. When we look at those trend changes, there's a significant increase in titanium. Again, this seems to be correlating with the increase in the clearance rate of the spine cages, decreases in polymer, decreases in knee and hip over that time period. And again, when we look at the second figure, the number of devices cleared, spine cages really taking off. So we see mass adoption by industry for making these products using this technology. If you pulled out the spine cages, I don't think the trend would change significantly, and you'd see the knees, shoulders, hips, as well as dental being pretty dominant. And this data is pulled from 2 sets of published papers. I think they're really interesting. Highly recommend people take a look. All right, so shifting to the questions that FDA asks. So we do have a technical guidance out. It was published in 2017. It addresses both what we call the pre and post-market technical considerations. For FDA, pre-market is going to be the information included in a submission. Post-market is going to be more general quality management expectations. How do you follow good manufacturing practices with this technology? It's designed to be technology agnostic. Again, for that previous slide, we see products using almost the full range of AM technologies, and it's really set up to supplement device specific testing. If you're a spine cage, you still need to meet all the spine cage requirements. If you're going to be a hip cup, bone plate, meet those, and the AM technology questions really supplement that. I'm going to go into a specific example of powder reuse that has been touched on a little, but most of what this guidance is really focused on is making sure that we understand how the process is controlled and what the worst case product is. At FDA, especially when we're looking at 510Ks, we want to test a worst case product in that family. You compare it against a legally marketed predicate to determine substantial equivalence. With the variability that additive manufacturing can bring in, it's very important for us to understand if you're running multiple systems, is one system worst case? Is there going to be a build orientation effect, build location effect? All of these are questions we have that we want to address to make sure when we're reviewing a product's performance, we understand that it's going to be sort of representative of the worst case of what's going to be brought to market. So speaking of powder reuse, we had a specific part of the guidance that focused on it. I'm not going to read through all the text, but there's 2 things recommended from the guidance. The first, that you describe your material reuse process. And then we also recommend that evidence is provided or a rationale is provided that the material reuse does not adversely affect the final device. So the first part, describing material reuse, this is generally most applicable to powder bed fusion, but there's some other AM technologies where the material can be stored between runs. So we worked with ASTM to develop a standard, and we have a standard guide now for powder reuse schema, ASTM F3456. It outlines 7 reuse strategies for powder bed fusion, certainly being used in submissions to the FDA. And the idea being that this can be a very quick and easy way to communicate how you're reusing the powder in these processes. So once that's been described and conveyed to the FDA, and I really should say there's no right answer to how you're reusing powder. We just want to understand how you're doing it to make sure that the appropriate testing is being done for us to, again, understand what the worst case production conditions are going to be. So here's an example. So this is all mock data, I should say. So this is an example validation of what we call discrete reuse. So this is going to be scheme 2 for the ASTM. And this is generally where a sponsor is going to say, we're going to have a discrete number of reuses of this powder. In our hypothetical example, they were going to run it out to 6. So to validate this, there's going to be tensile testing done at each reuse cycle. And then ideally, you either show that there's no statistical difference between the reuse cycles. That would let a sponsor then use devices made at any powder reuse for the performance testing, because based on their reuse, their system, their powder handling, we can understand that that's not going to introduce a new worst case. Or if there is a worst case, which we generally see at the end of the powder life, then the performance testing would be performed at powder at that level. There have been instances where hypothetically, looking at this data, a sponsor would say, we ran it out to 6 reuse cycles. We see that there's going to be a statistical drop-off. Therefore, we're going to limit the reuse to 5 cycles just to make sure that there's no worst case sort of set of build parameters from your powder reuse. Moving on to patient-matched versus custom devices, I'm going to open with what the law is, which I know is always very exciting, but I think is going to be useful to set the sort of perspective of the FDA when it comes to custom devices. All right, so this is from 21 USC 360J Part B, which I know just flows off the tongue. So there's going to be 7 requirements for a custom device. So the first one is that the device is created or modified to comply with the order of an individual physician or dentist. Again, we're now setting up the idea that these devices really are intended to be one-off. The second part is that it necessarily deviates from an otherwise applicable performance standard or requirement of this title. That's going to really feed more into the third part, where this device isn't generally available in the US in a finished form through labeling or advertising by the manufacturer, importer, distributor for commercial distribution. So even if you don't necessarily have a product that would meet this need, there can't be anything on the market. Again, we're really trying to get towards this is a really unique situation, which then leads into point 4, is designed to treat a unique pathology or physical condition that no other device is domestically available to treat. Part 5 is a little interesting because we're now giving 2 options. The first one is that the device is intended to meet the special needs of a physician or a dentist in the course of their professional practice, or it's intended for use for an individual patient named in the order of a physician or a dentist. So this is setting up an option where the surgeon may have to say, based on the patient's anatomy, my regular surgical approach isn't going to work. I need something to be special for how I'm going to do this surgery. Or you're saying, we need to have this device to specifically match to the patient. It's a little bit of nuance, but it's important to note that the FDA does allow the custom side to be on the need of the surgeon to address the patient's unique anatomy. The next part, part 6, is assembled from components or manufactured and finished on a case-by-case basis to accommodate the unique needs. Again, Mariana touched on this a little, where custom devices really can't be off the shelf. If you can take something and sort of the surgeon can sort of modify it or adapt it, I should say for the FDA, we don't have a specific case for an adaptable medical device. IMDRF calls it out. Some regulatory jurisdictions do have that distinction. We don't. But if a surgeon can take something off the shelf and they can tweak it to make it work, that wouldn't be a custom device. And this last one is saying that it can't have some common or standardized design characteristics to something that is on the market. So the entire product doesn't have to be novel for it to be custom, just it has to be sort of specific for that case, and there can't be anything else on the market that's going to work. So that's the definition. There are 3 limitations in the regs that sort of further restrict what you can do with custom devices. So the first one I think is really important for setting up point 2. That's that such a device for the purpose of treating a sufficiently rare condition such that conducting a clinical investigation on such a device would be impractical. So this leads into point 2, where the production of such a device under this paragraph is limited to no more than 5 units per year of a particular device, provided that such replication otherwise complies with this section. The guidance on custom devices, which I'm going to touch on the next slide, fleshes out what exactly counts as 5. I think one of the more important things is you can make multiple devices for a patient. So the surgeon during the surgery can decide which one he uses. Provided the rest of those are destroyed, that would only count as 1. But the idea here is that these devices are so unique and so rare that we wouldn't gain anything in conducting an extensive study of the device performance for safety and efficacy. So this 5 is really designed to limit the risk of patients, because per these regs, there's not any FDA pre-market review of these products. So 5 is set up to ensure that companies can't make too many products without testing them. But we also acknowledge the fact that for a lot of these conditions, it's not practical to do either a clinical study or a full 510K for, again, 3 or 4 patients. So the 5 is set up to address this risk. I think a great question is, if why 5, why not 4, why not 6? And I suspect 5 was a number that most people agreed upon to being a reasonable in this case. And the last requirement is that the manufacturer of these devices have to notify the secretary. In this case, it's going to be the FDA on an annual basis. And there's a lot of guidance on how you do this. So while you don't get pre-market approval from the FDA, this is even different from a compassionate use request where you come to the FDA to say, we have a specific patient, this is how we want to treat them, and we sign it off. There is no pre-market FDA involvement, but the company does have to do an annual report. Okay. So moving on to the FDA custom device exemption guidance. So the way this works is we have the law, the FDA then puts out a guidance to provide the agency's thinking about how you would comply with this. So this is a little bit more, I think, practical than what that law laid out. And this was issued in 2014. At this point, additive manufacturing was still pretty new. This was not designed to address additive, but I think it's a real strength of the team that wrote this guidance that we've been able to leverage what they did here for additive. All right, so section 5A of the guidance lays out what I just said. So custom devices are exempt from pre-market approval requirements and conformance to mandatory performance testing. So very straight out, if you have a custom device in the US, there's no engagement with the FDA before you do anything with it. Well, okay, when I say no engagement, there's no engagement for that product. when we hit the next bullet here, custom devices are not exempt from your design control requirements, device reporting, corrections and removals, and more importantly, registration and listing. So you have to register and list with the FDA for the custom devices. This then keys into making sure that FDA, when we get that annual report, we agree that you're making all the custom devices that you're allowed to. I will say a number of companies over the years have found out that when they submit an annual report, the FDA doesn't agree with their interpretation of the custom device exemption rules. Usually what happens is we inform the company that they need to come in with either a 510K or a PMA to continue making that product. So there are some checks to this process. FDA does take the annual reporting very seriously for custom devices, but it's designed to be flexible to meet the unique needs of these patients. All right, so section 5E of the guidance is what addresses what we call patient matched versus a custom device. So this is the language straight from the guidance. Patient-specific devices in general are ones which ranges of different specifications have been approved or cleared to treat patient populations that can be clinically studied. Very heavy FDA language, but this is where the concept of a design envelope comes from. So the design envelope is going to be where a company comes to the FDA and clears a range of sizes. Now, this happens all the time for regular devices. You don't come to the FDA with a single bone plate. You come to the FDA with a 510K or a whole range of sizes of bone plates, but they're generally discrete. You know, every couple of millimeters in length, you might have some straight versions, some that dog leg left, dog leg right, maybe some clover leaves, but all of those are going to be very discrete sizes. During the FDA review, we can go through and determine for each of the required testing, which design is going to be worst case, have the company do that testing, and we can then agree that we understand the worst case performance of all of those devices in that family. When we look at an envelope, we no longer have discrete sizes, but a company is going to come to the FDA and say, we're going to clear, or we're seeking clearance for, let's say, a bone plate that's going to have a minimum and a maximum length, a minimum maximum thickness, and a range of curvatures. We can look at that, work with the company to agree whether or not they've done the testing on the worst case design in that envelope, and then we can clear that 510K. And so long as they're working within that design envelope, each of those products is going to be matched to that patient's anatomy. It's not going to be custom. There could be an instance where you have a company that has a patient-matched product, and there's a need for them to go outside of that clearance. That could be an instance of a custom device. Maybe you need a product significantly longer than is in your design envelope. Maybe there's a bone defect significantly larger than was ever considered for the product, and you're going to need to, again, take that base design and go outside of that clearance. And when we go back to the law that covers custom device, some features can be on the market, just that entire product can't be. So there can be, again, some wiggle room here, but generally the goal is for us to have as many patient matched products where we have that 510K, we've done the testing, so we can make sure that the products are going to be safe and effective. When that's not practical, again, when the number is going to be too low for testing to be efficient or for there to be a clinical study, that's when things generally fall into that custom device bucket. We don't like, FDA doesn't like to say customized. We prefer patient matched or patient specific to avoid any confusion. And as I already mentioned, while IMDRF does call out that the adaptable products, for FDA, we have sort of custom or not custom, with the patient matched being that sort of envelope submission where companies can get products cleared or can get products cleared to then match to a patient's specific anatomy. I will say I have seen a few cases where there is an envelope that also includes a surgeon's preference. Seen this a few times in some plates where a surgeon may opt to change the location of screws or other fixation options. Again, those go through the FDA as anything else with a design envelope, but it does allow some companies to match products to a surgeon's preference. And with that, I'm really happy to be able to virtually participate. This is my email, and the additive manufacturing group also has a dedicated email as well.
Thank you, Matthew. Thank you very much. We, from the organization here, they asked if you could, we could do a picture. Are you listening to us?
Yes. Yes.
And at the end, if you could stay online, and then to have a picture with us. Okay. So thank you very much for this great presentation. I think we have a lot of in common as we are in the IMDRF. Our resolution was published in 2019 with the same contents of IMDRF, and the concepts are, I think, the same. Maybe the way how to organize and tools for regulation, we have some differences, but the main concepts and how you are dealing with these things are the same. Esqueci. Era pra começar, pra gente falar em português, né? Melhor.
We're supposed to speak in Portuguese, right? He is listening to us in English, right? You have a translation. So I think the concepts are really similar. They are equal, in fact, because we had as base the IMDRF document. It was our base as well. So to bring some questions here, which will be interesting to be answered, we would like to understand a little bit more about, from Matthew, how was the matter of the understandings are not regarding this part? How do you deal with that? You have the notifications, you have to review them. And sometimes you have the need of getting in touch, I don't know, with the companies and define if you need to register for a specific patient, 510K. The question is, how do you deal with that in your daily routine?
There are a number of submission types to come in through the FDA. The 510K is the most common, but each one has a different timeline and a different regulatory expectation. So for me, in my role, a lead reviewer in a product area, so if it's an orthopedic device, it goes in through orthopedics. If it's cardiovascular, it goes to cardiovascular. They come in and they will say, Matthew, we have this device. You have hopefully 2 weeks to review all the testing. On a bad day, it's, can you do this by tomorrow? I review the company's testing and I write up a list of questions to go to the company. And those questions and the requirements are going to be based on the product and the submission type. That information is then conveyed to the company. The company then, per the submission type, has a certain number of days to get back to FDA with a response. So usually the way it works is someone comes in and will say, okay, you did a good job following the guidance for additive manufacturing. there's a problem with how you did your residual powder, or for something very porous, there's too much residual powder in the product to be substantially equivalent. So we then tell the company either do more testing or provide a rationale. So there's a lot of back and forth at that point with the company and the FDA. Now, all of this is sort of predicated on the previous registration and listing, and then the 510K. For a truly custom device, each year you submit to the FDA a list of the devices that you've made that were custom and the justification for that. And then there's a separate review of all that documentation. In most cases, I'll say, the FDA agrees that with the company that everything they did was custom. Every now and then, there may be a dispute over that. And generally, when FDA disagrees with your use of the custom device exemption, we ask that a 510K or PMA comes in.
Sim, a gente.
Unfortunately, we are almost out of time for this panel. So because of that, I just wanted to check if anyone here in the audience might have a question to one of our speakers. I think there's a question in the audience here. So before we take Fabio's question, I have a question to him as well. Even with the short time, we don't have a lot of spare time in our agenda, but Fabio is here, and I think it's important to hear his perspective about this industry in Brazil. The number of installed machines in Brazil doing additive manufacturing. Thank you so much. Thank you, Matthew, for being here. Thank you, Ricardo, as well. Thank you to all the speakers. Actually, my name is Fabio. And answering Dr. Sergio's question, today we have 8 companies in Brazil working with implants manufactured through additive manufacturing, all working with powder bed fusion. If I'm not mistaken, 5 companies have products or registered products in ANVISA. So they have the possibility of applying this technology in registered products. Now, my question is quite simple and straightforward. I would like to know both from Matthew and Ricardo how comfortable you feel in presenting medical devices manufactured by additive manufacture to the regulators, both internally in the case of Matthew and the industry. How comfortable do you feel in submitting these products?
Ricardo can answer first since I answered the last question.
Sure. Of course. It's a very interesting question, to be honest. I think a lot depends, of course, on the regulatory, I would say, on the country where you are applying, for registration, because along the years, and especially in the last years, a lot of changes happen, especially in Europe, in terms of regulations and boundaries. So what was, I would say, typical in Europe, then basically flipped in some way. So I would say that when we have to develop something from really that is not, I would say, available in the market, there are multiple ways where we address this, and there are multiple ways where you can, start a dialogue before submitting, for example, to a regulatory bodies in order to understand if you are not, I would say, if it's something really, really different from a predicate, there are ways you can maybe approach and so be comfortable, in going on with your development, your application, having a fair and open discussion with different regulatory bodies across the world. And we did that different times, and this led to, for example, to IDE in US, right? Or a different path in other countries. So I think that from a general perspective, we are quite comfortable. Of course, the scenarios are always changing, and as we are changing companies, but I do not see this as an obstacle, but rather than a positive thing for the development of the technology and the industry and for the patients as well.
Okay, thank you for your answer.
If we still have time, I think it's more application-based. Again, anything bone interfacing, a lot of history. We've seen a lot of products coming in. But when additive is used for the first time in a product area with a group that hasn't seen it, that's usually where I need to go in and give more of a talk about how additive works and what to be looking for. So certainly some product areas, especially orthopedics, very familiar with the technology. Everyone's very comfortable seeing it. Some other application areas where it's less used, that's where I think there's still a little bit more hesitancy. But again, I think from the technology, there are enough standards now and enough understanding that we know what questions we need to ask.
Thanks a lot.
Gente,
So I would like to thank all of our speakers. Our time is unfortunately over for this session. And if you have any questions that you need an answer to, ABRAIDI is committed to sending the questions to the speakers so they can answer them at a later occasion. So with that, I would like to thank you for the opportunity of moderating the discussion between such great experts. And I would like to thank them for sharing their experience with us so we can bring clarity about the information and pretty much improve this industry globally, because this is what we need. We need to share knowledge and share experiences. And we all need to do our best to try to improve the products and make them more accessible and safer for patients. And now we're going to take an official picture. So we're going to ask our two online speakers to please leave their cameras on.
Bom, muito bem. Enquanto ele...
So while we take the picture, I would like to thank you and mention that besides those of you here in the auditorium, we have more than 300 people watching us online via Zoom. Thank you again to our speakers. The photo has been taken. You can close your cameras, and I would like to call the next speakers.
Então vamos ao painel número...
Let's start our second panel, which will discuss stability, storage, and expiration date for medical devices. I would like to call on stage Patricia Branco from ANVISA to moderate the discussion.
Sandro.
Our speaker will be Mr. Sandro Otamoni, RA Manager at Braile Biomédica, Brazil.
Bom, uma pequena orientação técnica.
Just one housekeeping message to speakers and to everyone asking questions. Please don't hold the microphone at the antenna because it stops working if you do so. Good morning, Sandro. Good morning, everyone. It's a pleasure to be here. It's a pleasure to be here talking about such an important topic to all of us. Stability, expiration date, and storage of medical devices. This is a horizontal topic that affects not only regulators, but also manufacturers, the whole distribution chain, distributors, and users. And we believe that by having better information about this matter, we can truly improve the safety and the quality of our products. So now, I'll hand the floor to you, our speaker, so you can start your presentation. And later there will be a Q&A session. Thank you so much. First of all, I would like to thank ABRAIDI and ANVISA for the invitation to speak. It's a pleasure to be here, sharing experiences with all of you. It's a great opportunity for us. We've mentioned that yesterday and today about the importance of these events to us and to the medical device area, and to really give us the opportunity to discuss an area which is impacting the whole of the population, basically. Everyone at some point in time will need a medical device. And we're here for the common good. We need to focus on the patient, those receiving our products, our end users, because what we need for them is safety and efficacy. So thank you again for the invitation. The idea here is to share just a little bit of information with you because I believe you're quite knowledgeable of the topic, but share some ideas and share experiences among everyone who is with us, especially the regulated area and our regulatory authority who will be here to have the conversation with us as well. I work at Braile. We manufacture medical devices and have been doing so for more than 40 years. We are a national Brazilian industry. We are based in the inlands of the São Paulo state, and we have a lot of options for having fun because we have class 4 products with animal tissue, heart valves, transcatheter valve. We produce stents. We produce patient-specific stents. I cannot get that wrong after the previous talk. We manufacture electromedical devices and class 2 materials. Tubes, cannulas, we have a little bit of everything. So if you work with regulatory affairs, you certainly have the opportunity of working with an array of products. What about me? Well, I'm an electrical engineer. I have been at Braile for 22 years, so 22 years of experience in this universe where we operate. And today I'm responsible for quality assurance and quality control. I'm also leading regulatory affairs in the company, and I'm also leading our compliance efforts. So after the previous talk, as an engineer, the discussion on additive manufacturing and customization, and all the legal components associated with the development that we really like. Now it's time for a more boring discussion, so to speak. So I'm here to share some experience with you and discuss a topic that might not be so interesting, but which is essential. So stability, storage, and the expiration date of our medical devices. And I'll tell you why this is not so interesting. It's not so interesting because every little thing here has its own time frame. It takes time. It requires studies, a lot of planning. And even though we have international guests in this event, in Brazil, we don't do a lot of planning sometimes. We start doing things, we start testing them, and only after that we stop and think about the results and we think about making a plan. And this is why this is such not an interesting topic. We have to really stop and plan everything that we're going to do. But at the same time, this is an important step to ensure quality and safety. I did my homework and I searched for better definitions or perhaps deeper definitions of these three concepts. So, stability is the ability of maintaining specifications during the shelf life, is the possibility of the device preserving safety and performance features within the time frame defined under predictable environmental conditions. It looks at effects coming from temperature, humidity, and light, and other external factors to ensure the quality and safety and efficacy of the product until the end of the established period. Storage are conditions and procedures to preserve the device during its shelf life as to preserve efficacy, safety, and quality, including environmental controls to avoid damage, degradation, or contamination. The storage ensures the product will keep the specifications all the way until the expiration date. And last, the shelf life, which is the period in which the device will remain safe and efficacious based on evidence. We're talking about science here, basically. And it determines the maximum time of use before a significant deterioration of the product. It is established through stability studies, like I said, science, considering transportation, storage, and use. And the goal here is to ensure the functional integrity of the product throughout the whole shelf life. So this was my homework, like a pretty nice, clear definition on the concepts, just so you understand what we are talking about when we are discussing stability, storage, and shelf life. However, in reality, stability is a fight against time. This is what we're doing, basically. It's the ability of a product to keep its specifications throughout its lifespan. How do we do that? I mentioned this is science. So, how can we start? How can we start discussing the stability of a product? First, we need to assess the functionality. For example, we manufacture a stent. I need to ensure that a stent has the proper radial force throughout its shelf life. We also need to investigate the integrity. We need to look at the product, the color, or identify any type of physical degradation. A cannula is made by a plastic material, so I cannot not allow it to be dry. I have to look at the physical integrity of the product.
I also have to look to sterility. Sometimes we talk about sterility, and the first thing, stability, the first thing the person thinks about is only looking to sterility. But I did sterility testing. I put in a Tyvek the medical paper, but the stability of studying all of that. We need to assure that all over the time period, I told you, we're fighting against time. We need to assure this product will be uh, untouched inside the packaging, no microbial contamination, no problems to the health. And of course, in the meantime, we need also look to the biocompatibility. My product cannot release a toxic substance after this lifespan, after this time period, assuring the biocompatibility all over the time. How do we do that? Studies, science, real-time studies. So the product is there aging in their real time so we can assure their guarantee their stability. But we also have techniques, accelerated aging studies based in statistics, standards, and so on. We are always seeking for limiting environmental factors, temperature, light, humidity. We work with all of that to be able to guarantee the stability of product. And of course, packaging studies and their durability, the interaction of the packaging with the device. And for such, we have a database for that. We have standards, ISO, ASTM, we have guides, many statistical methods to work with this prediction of information, guides, international documents, which are a reference for this feasibility study analysis. But the question is, if your logistic chain changes, the stability studies will still be valid. We need to take care with that. And I'm blaming myself on the side of manufacturer, the regulated sector. We need to make alterations in logistic chains, and we need to really think about this impact all over the logistic chain the product will be through. We only think about when it's inside the company, how it's going to, what things are going to happen after that. It has to be vital to us, and we have to be able to control that. I told you stability is a science, so it's going to support our expiration date and storage of medical devices. And storage, if we're talking about time in stability, we're talking about the guardian of stability. Storage is the guardian of stability. It will assure our product will maintain all the characteristics, everything we assessed. Physical integrity, biocompatibility, sterility itself, the functionality of the devices mainly, this is the one that will support that, because if the storage fails, everything we test in the lab can be lost. We will lose the guarantee on what we were searching as evidence to support the stability of our product. Well, storage is a guarantee for the value stability, it says, up to the final product, the final time when the product will be used. It's part of our assessment to guarantee this stability, this time when the product will be maintained in a storage that will guarantee the size will be valid up to the last moment. What are we trying to do? How do we control this kind of things? Well, environment, when we talk about storage, the first thing we think about is environment. I need a certain temperature, a controlled temperature range. I need to analyze excursions out of this range. What can this represent for our product? I need to work with guarantees that these ranges will be monitored. So temperature, humidity monitoring. We need to know how it will have to be. Our search for information on how was the temperature range, how it oscillated in the time period it was stored, animal origin products, temperature sensors, dependency, the ones that have a dependency on a critical temperature. The manufacturer putting also in the device a way of checking if it's out of the for the temperature ideal for the storage, the conditions, the specified conditions in our label, temperature, humidity conditions, the so-called clean, dry area. We don't know certainly what is that, but it's a nice sentence we always say, we always put on our label. Extended distribution and qualification of suppliers. It's not only taking care of the product inside the factory, all the chain, the logistic chain, all our tests, validations can be lost. So we need to search for that. Storage is the search for monitoring, guaranteeing the product is inside the proper conditions, do assessments in case of excursions out of the values, the range. How will this affect the device? What is the impact? What is the guarantee that it will not damage the medical device? And again, this is a study technique. We have guides, statistics to help us to get the information. It's out of our storage. How long? What is the condition? What does it mean? What will this cause to our product? We need to know that. And we're talking about warehouse, temperature monitoring, recap of refrigeration, air conditioning in warehouse of the environment, the electrical system, checklist inside the factory with assessment when we're talking about sterile product, assessment of the packaging, how putting a product inside the packaging can make damages to it. There are the standards, it needs to be assessed, and inside the factory we have many devices to try to control this kind of thing. And why is that? Because storage will be the bridge from the manufacturer and the end consumer, the patient. As I told you, one day everybody will have to use that, and we want the product to remain safe, efficient, and with a good quality up to the end of its shelf life. We need to guarantee this bridge will work. But do we know this bridge? In fact, do we look to the whole path our device goes through up to the patient? The truck is for a while under the sun. And there's a reagent, something that cannot react to higher temperatures. I have a catheter that was leaning to an external wall and the temperature was over the limit. Will they lose flexibility, or even the storage position? A real case. One time there was a complaint about a catheter. It has to be stored in horizontal way. The catheter it looked like a S shape. It was an S shape because it was stored standing up. So the weight of the device made the catheter bend. So we need to look to this path that our device will be through, so we can assure the safety and efficiency of it. When we look to this kind of thing, this is very rich when we think about all of that. When we start to travel all over Brazil to find different situations where we can see our devices being submitted to, we bring a lot of information, a lot of important information for the risk management, so we can assess the storage of the medical device. I told you about positioning, the stock access control, for example. when we think about access control, people think about this is for nobody get the product out of this warehouse without requirement, system requirement, and things like that. You think about the product itself, the lack of the product, or the fiscal issue, things like that. The access to warehouse is more complex. When we look at that, we need to think that people can access the warehouse area and they are not trained properly, and they can change the position of a product and causing this kind of damage. We need to assure this bridge will happen in the best way possible. Do we really know the way our device is traveling all over Brazil and the world? And, and for last, validity, expiration date. We're talking about the promise we made to the patient. We have a nice tax, we have a homework, but expiration date is a promise that my product will last 2, 3 years, 1 years. We will assure that up to that date, the product will be safe and efficient. It's like a yogurt. It expired today. I cannot eat tomorrow. That's exactly what we eat, what it is. I should not. I don't need to mention to you the risk of an expired product, a medical product. We don't have the study assessment of stability after that day. So an expired product is more than a logistic problem. Sometimes it's a logistic problem. You don't have a larger expiration date. The hospital used it. It can be a logistic problem, but sometimes this is the the minor problem. What will this cause to the patient if you use an expired product? We don't have how to guarantee the real performance of this product when it's going to be used. How do we define that? Shelf life, scientifically defined shelf life. It's a science, the boring part. We need to look to the devices and know that. A real study on the shelf life, real-time study, accelerated studies, in interaction with packaging, transportation studies. There are many standards dealing with that. Will I transport by truck, plane, ship? How will I transport this product? So we need to make the analysis of all of that to predict the expiration date. Conditions also, the transportation conditions, the shaking of the truck all over the roads in Brazil or in the world. Also, temperature controls, environmental controls along the transportation of the product, and also storage, so it will be guaranteed. Clear label. The user needs to understand the date. Everybody's been through that. And what about this date? Is this product expired or not? Because the language was the one in Brazil, month, day, month, year, and US is month, day, year is different. So there's this confusion that we have because of the product. This is something simple we need to think about. So when I talk about risk management, we need to think about that. Will they understand exactly what I mean with my expiration date in this product? This is important. It's important to be controlled. Periodical review via technical surveillance and post-market information. The market will bring a lot of information on the product, how it's behaving, so we can retrofeed our information and we can have an interference on the expiration of the product. It can be a positive, a negative one related to the expiration date of the product. This is very important. It's important to take it home. Have we defined really a expiration date for a product? And is it really a realistic one, looking to the market, looking to the way the product is behaving, how they are using our product? Does it make sense for us, in fact? If we're talking about stability, storage, and product validity, I think it was clear to everyone, and it's even clearer now that one thing is related to the other. You cannot talk about expiration date without thinking about storage, stability without thinking about the durability of the product in warehouse, and so on. It's not about one thing only. This is a tripod of things that directly impact the safety and efficiency of our product. This tripod will give us this support, this security, the promise to the patient, as I told you. It will guarantee our product is safe, efficient all over the validation period, and they will take care, at the end of the day, of the image of the company. This is a boring subject, but it's necessary. We need to use and stress out all the possibilities, the techniques, the methodologies we are aware to assure all of that, because we are really guaranteeing that the image of our company is the right one, how we'll be seen by the market. The importance of safety and efficiency in the devices, this tripartite, and the stability assures will have critical properties with time. The product will maintain itself stable. It will reduce the risk of clinical failure arising from materials degradation, among everything we assessed with time. Storage will assure proper conditions to prevent physical, chemical, and microbiological alterations. It will preserve sterility and functionality up to the moment of the use. Expiration date will define the time limit that safety and efficiency are assured, and will prevent the use of devices out of the verified specifications the manufacturer wants, establishes, and studied, so it will be controlled and they will assure the safety for the device. I mentioned earlier about that I'm engineer, telling you about boring things, but engineers like innovation. We've been discussed a lot about that. Yesterday, you mentioned about AI, innovation. This is something we have to look at, and we've been mentioned a lot that the world is changing. We have a fast evolution of things, whether due to AI, knowledge, proximity, despite the distant or facility to access information or share information. But the fact is the world is really changing, and we cannot look to innovation versus safety and efficiency. They have to walk together. As manufacturers, what we are looking forward as the ones that are manufacturing the devices, we are always looking for regulatory flexibility based on science. They have to be anchored by robust data. We're talking about science, not imagining things, not because I want things to be like that. But we need to have this alignment. We need to seek what is worth it abroad or in Brazil or US, Europe, reach a consensus. We've been talked a lot from the use of normative standards or reliance. We talked about here in the last 2 days. Validated use, we need to seek that for accelerated studies. This reduces a lot the time frame and will not compromise the compliance of the data we have. These are statistic data, consecrated, spread data, and makes things easier for us. International harmonization, as I told you, minimizing any divergences among ANVISA, FDA, and Europe. I know about all the efforts. I'm following you. But once again, this is about, as Clariana said, we are trying to get what we want. So let's try to have a conversation. This is an important moment as well. Having this talk on what you're expecting from me, up to which point can I go? How can we discuss things so we can improve, so we can have reach a consensus which is more favorable for everyone. Transparency in technical justification, clear documentation, reproducible and auditable documentation. As I told you, I'm from the boring part because the development guys, they create this dossier. I'm the first one to block something. So documentation sometimes is not clear. Us inside the company, looking to the product, sometimes we're not able to understand. So this is our job here. There are a lot of voodoos of me running all over the company because I need to block things, and I say we don't have conditions to deliver that. And sometimes I tell you, if deliver that, I'll be embarrassed in front of ANVISA. This is our face in front of before ANVISA. That possibility of proximity we have with them, and we waited to keep on happening, increase. ANVISA sometimes is not looking. It's not Braille. Sometimes they say, it's Sandro. It's put my image in there. This is worse. It makes things easier in one hand. It helps us. We are glad with this interaction, but also Sandro let this pass, delivering this dossier. And so
We need to have this level of transparency so information is provided the best way so it can truly be audited. Training and improving the whole value chain. It's not enough to think just about us and the things we can control and what we do for our devices, because we also have distributors and sometimes they don't have the proper environmental control. Sometimes hospitals might receive their product and they put it in a first storage room in a very warm city, and in the first storage room the product's going to be outside the hospital and they receive different types of products. So what could that do with our product, right? And we also have the impact of the users. And the idea is to ensure use is compliant with the requirements. Regulatory integration versus technology innovation is another issue. I often say that, especially in the company, we cannot block technology advancements due to excess red tape. Regulating is one thing, but just adding more bureaucracy is something completely different. We really need to optimize processes, even in the regulatory affairs area. It's important to have a balance between technical robustness or solidity and regulatory costs. I think this was mentioned before. Access is an important component of our mission, and I think this is a shared mission. We are all working for the patient, but at the same time, we need to ensure access, because without that, we cannot help them. We won't be addressing their issue. And a continuous communication between the regulated company and the regulator to reduce any misinterpretation or the need for reworks. This is a continuous path that we would like to establish with the regulatory authorities. Innovation versus safety, because again, stability, storage, and shelf life are way more than just essays. This is a true science, and they are the guarantee that the patient can trust our work, they can trust what we are doing. So this is what we strive for, producing information on the stability, the storage, and the shelf life of the product all the way until clinical use. So this is what I had prepared for you. I just wanted to share a little bit of this information, a little bit of our anxieties and requests. These are topics that I believe you are all familiar with. We're not talking about additive manufacturing, even though they mentioned this is not something new as well. But I think these are quite common topics that we see. And that was the idea, to talk a little bit about what we are looking for and what we expect when it comes to this topic. So thank you for your attention, and I'm available for questions. Sandro, you raised so many interesting questions for the discussion, especially when you mentioned about the need for more clarity, informations that are submitted, and I'm speaking on behalf of ANVISA here. When we look at a technical documentation for the analysis, it is very important to see the coherence between the information that's being shared, the studies that were conducted, and what can actually be being proved. For example, a certain shelf life or storage condition, having clear information in the label as required by our standard. And speaking of our standard, it introduced many progress without adding bureaucracy. So it allows us to think on a case by case basis. In your opinion, do you think this is a strength or a weakness of the standard? Because Clariana mentioned we work in regulatory affairs, so we love when a piece of legislation is developed so we can just comply with it. But in this specific case, we don't have all the topics fully described. So I'd like to hear a little bit of your take on that. Yes, everyone working with regulatory affairs really love a guide or a standard. I often say that in the beginning of the development, I often ask, did you actually look at all the standards and everything that's there? Oh no, we're going to sterilize this using ETO. Okay, we can do that. But for this specific product, is that possible? Is there any specificity to it? I talked about risk management. And today the standards, they talk about the main risks associated to the product. And maybe there's an interaction between that sterilizer and the product. So I think, yes, we really like a standard, we really like a guidance, but the Anvisa standard certainly gave us information that helps. But again, maybe having a more specific guide so we don't have to do this on a case by case basis all the time. I think it would certainly help us in this communication. So we don't have this back and forth. Oh, I don't understand this, because sometimes we can't understand. We have talked about this before. I was once talking to Patricia and I told her the best way to send a submission would be on video, not on paper, because there's only so much you can put on paper. And we don't share everything that went wrong. We have the history, the track record. Ideally, we would film everything. Guilherme mentioned this yesterday. Every case could be made into a Netflix show, but maybe a product dossier could be made into a movie. I think it would be much more convenient. I don't know if we can ever get there, but I think having a guidance certainly that helps us solve these type of questions or issues between the regulated industry and regulators. This is very interesting. I would love to watch a video. It would certainly be more interesting and much easier to just watch a video with all the data. But unfortunately, as I'm sure you have heard before, we don't have enough staff to really dedicate the time to watch one more Netflix show. That would be excellent, though. And you're going to be, of course, criticized for watching TV during working hours. Yeah, we're supposed to be reading. But it would be much more interesting if we did have that possibility. Now, you talked about the level of the data that needs to be presented. It is a study. There's science and there's methodologies that need to be used to establish the parameters. And like you said it yourself, we need a clear definition of those in a packaging, because in the end, we have a whole value chain that needs to be controlled. It's not only on the manufacturer's side, because at the plant, all the employees know about the procedures. But after that, the product goes through transportation, hospital, and use. This is very important, and this is one of the things we are actually looking for in the technical documentation. Well, I think we can open for the audience now if you have any questions. Hi, my name is Deborah. I represent Boston Scientific, and I'm going to disagree a little bit with you. I think having a guidance for such established topic might not be the best way to go, because even though there are gaps in the regulation, it determines what should be done and not how it should be done. When we're talking about good regulatory practices, we are evolving to that scenario, not really talking about the how, because we have really well established standards. We haven't seen a change in the stability standards in a very long time. And maybe a guidance would restrict the possibility and eliminate the level of flexibility we have. So the way it is done today, the standard 751 allows us to look at the standards, look at the products and the innovation that's coming. Even though we use well-established materials that are not affected by temperature variations most of the times, but I really like to see this type of evolution. And I use this an example when I talk to in Metro, because in Metro, the Metrology Institute, they're very prescriptive. And ANVISA gives the decision to the manufacturer as long as we comply to what is on the standard. So in my opinion, this is a very interesting way to work and one that is very much aligned with IMDRF. I'm Clariana from Link. Just adding to Deborah just said, I believe that in this case, a restriction could cause issues due to the diversity of medical devices available. One thing is to deal with hyaluronic acid for as a filler, and something quite different is a metal titanium prosthesis that you can just stay there for 30 years. So we would need to get too much down to the detail, and that could create restrictions. But I wanted to understand one thing, because we often get feedback from Anvisa asking for more details on storage conditions of the products, considering the stability study that was presented. But for metal-based products or ceramic products or polymer products, sometimes we do a stability study that couldn't establish a range. It just says like room temperature and dry, protected environment. So I just wanted to understand, do we have this flexibility and how is this being dealt with? Is it on a case-by-case basis? Is Anvisa making a difference between critical and not so critical products when requesting this type of information in the submission? That is certainly taken into account on a case-by-case basis. The type of product, the storage conditions, all of that is taken into account. It's difficult to talk about a generic case, but this is a very important discussion because we do take into account the type of product, the storage condition, transportation and location, because again, Brazil is huge with a great deal of variability when it comes to temperature and humidity conditions, which certainly can influence depending on the type of packaging. So that's why it's important to study the packaging as well, so we can ensure the product will be preserved throughout its shelf life, regardless of the location where it's being stored. And if there is a need of a specific storage condition, it's important to have that information on the product packaging, of course, respecting use conditions. But that is certainly taken into account. So, but the guide, about the guidance, sometimes we think about it for one type of company, because again, the guidance would be much helpful for us, especially for our analysis. And actually, maybe as a suggestion, if you want, maybe create a study group with the associations to discuss these possibilities with us. That is certainly a welcomed initiative, because we don't have enough staff to do everything we wanted to do. We do only what we can, considering the shortage of staff we have. But we believe that your experience, your information in the real world, this is very important as well. So, just as a suggestion, if you can have these discussions and present them as a technical discussion or perhaps a guidance, we would be very grateful. Just adding to that, Deborah, is not that I don't think you disagree. I was saying that similar to what Patricia just said, sometimes we just look at a company. I believe that, I don't know if it's necessarily a guidance or not, but sometimes we have standards with a Q&A session or a frequently asked questions session. And that already provides us with some orientation. Again, the idea here is not to create barriers. We just received a task. We still don't have a deadline for the task we were just given, but maybe this is something that we need to do. Because the idea is to have something to help us in the process. But I think we agree on that. I don't think you disagree at all. Well, you give us a lot of work every day, so it's only fair. But this is a very important discussion, expanding our knowledge base, because that can certainly contribute to our routine. Because again, we don't always have access to all the information, and we not always have full knowledge on all the products you manufacture. We still have time for one final question. Sorry, one question in the back, and then we close the session. Good morning. Thank you to the speaker. My name is Patricia. I come from Johnson & Johnson, and my question is to Patricia as well. Do we have a regulatory impact analysis or data showing us that we have had issues associated with stability recently? Because some companies, when we know this from meetings in associations, some companies are receiving questions about stability issues. But what generated that? That's not clear. Because I agree with what Deborah said. The company conducts many validation studies. The companies produce a lot of reports, especially importers. We have all the validation studies showing and proving everything. We have all the local controls in place. So do we have that data on what generated the question on ANVISA side? I think it would be nice if we could understand why the question is being asked, because this is an opportunity to discuss that. Just to understand the root cause of the questions, because there are other topics that we prioritize in the discussion. So the idea is to try to help and perhaps do deeper analysis if required.
Falou, e a gente está falando por...
Just adding on what Patricia said, this is the subject of the moment. We have received requirements and denials, and what is causing is that what we need to do, what we call IFU specific for Brazil specific IFU, use a specific use for Brazil. There's the global and the Brazilian one. So I can put a range of temperature. What I've been talked a lot, we will have this conversation here, right, Patricia, among us, right, between us, is that in fact, this is a integrated data analysis, as Sandra highlighted. We're talking about stability studies. My international team disagrees a little bit on stability um, because they say it's about aging studies, sterility studies, packaging validation, and transportation simulations as well. It's also part with risk management, all of that together, integrated analysis with many technicians, scientists from all the areas, so you can reach a result on what we'll put in use instructions, and it will be the essentials, not to put a overload on that product. I mean, the product needs to be from 15 to 30. This means something. It means you need to do the whole chain from 15 to 30. Does it really need to be 15 to 30? This is what we've been talked about. And we want to bring this to you because we understand that everything that is put in the label is everything that they should pay attention and without distractions from the essential. Patricia and Deborah, thank you for the questions. I think we can go deeper in these discussions. However, as long as regulatory agency, we need to think not only from the imports, but also what is produced in our country, the way it's distributed, possible storage places. This is also part of this set of things. And the technician, when they analyze the document and saw and felt the need of make this question, they have a base. They had this question, a personal, whether personal or because things are not clear enough and they made the requirement. This is a natural process, a routine for us having these questions made. And I think if we're seeing a trend, we can have a meeting for a specific discussion on that matter, also bringing specific cases about what happened, and we can move forward with this conversation. I think that this is the way. I think that's all. Dr. Sergio, he's here. I think we can close this panel, right? I would like to thank you for the invitation, for being here, also on the possibility of increasing the knowledge, exchanging ideas. I think GGTPS is always open for dialogue. We believe this is the best way of growing, and also this sector, and also making this country a better one and a stronger one. So thank you so much for your everything you brought here for us, everything you told us today. Yes, thank you so much. Good afternoon for you all. Please do not forget the official picture. This moment is really important. Thank you, Patricia Branco and Santo Ottoboni. Now, straight to, after the photo, we'll go to the next one.
Dispositivos implantáveis com micromotores.
Implanted devices with mechatronic micro engines. Anderson Almeida Pereira is the moderator, G-Equip manager at ANVISA. And to talk to him and to all of us, Lucio Bonato, market development manager from Orthofix. Welcome.
Alô, alô. Bom dia a todos.
Good morning, everyone. I would like to thank ABRAIDI team for the organization and the support, Dr. Sergio mainly for the invitation, and I'm really excited with your presentation. I'm looking forward to it because it's an innovation to me. I'm a mechanic engineer, and mechatronics part is really interesting to me. Spoiler alert here, I've seen the presentation, so don't go away. So Lucio, you can start now. I'll try to be as brief as possible. First of all, thank you for the invitation, ABRAIDI and ANVISA. I thank you all, Vanessa, mainly for offering me this moment of presentation here. I'm product manager, marketing manager at Orthofix. I've been there for 14 years now. It's a pleasure to present this product with something that changed the rule for us. Onboard technology implant with entire system, not only inside the implant, not only in the control set, but a software add to it, to the whole surgical planning. Orthofix is a company created by a doctor, Dr. Giovanni Debastiani. It's an U.S. company today, but it started in Italy. We still respond to Italy. He started with a simple product. He created a company, a whole company, with 40 years of market, 1,600 employees in 60 countries, divided in enabling technology, spinal implants, biologics, bone growth, electromagnetic pulse emission, and we are in orthopedics. Orthopedics, we have all these products here. We are working from the most basic product in the market, the tubular implant of a patient arriving to emergency and is seen by a doctor, up to the onboard technology products or exapodal systems. Our values, our view, taking on responsibility, innovating with being bold and winning together. What is Fitbone? Fitbone would be, in the first view, it would be only intramedular stem. Femur, tibia implantation, and it would do bone elongation, but it would be more. It's more for us. It's a concept, a system for correcting deformities and elongation. It has a whole system of tooling, developed tooling system, and a software system helping the doctor and the patient to make a correction of a deformity and elongating the member at the same time. It works with 3 principles. It's accurate, it's strong, and extremely adjustable to the bone of the patient. Accuracy, so it makes easier the elongation. It protect soft parts, so minimum invasive. You see the difference, what would be a minimum invasive implant or not. And when you put the bolts at the stem, there's an entire concept of bolt placement. It's not only proximal, distal, and so on. You have the whole concept of bolt setup. It is strong. It will receive this strength, this force, like a charger. The charger will send a signal to this emitter. The stem has a receiver on the skin, and it will do the elongation with a servo motor. And there's also a concept of milling, which is really needs to be careful because they are really sharp. Is this a new product? No. It started in 1999 in Germany. It's being developed for a while. It's new for Brazil, but it has a while. It's been for a while. It's out for a while now. It's a stem in a medullary channel, femur tibia bone with emission and reception systems. What will we do? Osteotomy, and it will elongate and equalize the size of the patient's members for femur and tibia. This is control set. Control set is handled by the patient. I will tell you about that. It emits a signal like a cell phone charger. It's charging the engine, the servo motor inside the stem, and it does the patient's member elongation. And you see the difference in here. You see the difference of the position of the knee, and you see the alignment of the knee. This is an institutional video of the product.
Mostra a haste.
This is showing the stem, the servo motor inside the stem is implanted with under skin implant. Subcutaneous implant. All the concept, the measurements are done in X-ray, put in a software, and it helps us to correct the deformity of the patient, because it's not only about elongating the member. When we do that, it can generate some deformities arising from the elongation. So I need to work with the fragments in a way I will not generate another problem to the patients. So the patient has a normal life. There's this receptor that goes with them, and every day it will press the receiver three times a day, each 8 hours, and this power will be sent to the elongated stem. And they follow this. I will show you how it was done before in our daily routine of a patient with other implants. So the engine pushes the piston, and then the stem grows. You have the minimum invasion of the bone, and implantation of the stem is really tied to the medullary channel.
Plunger.
Eu consigo aumentar.
I can increase 4, 6, or 8 centimeters, depending on the type of the gap, the difference between members. This is what we used before fit bone: aluminum fixators, carbon, hexapodal, and monolateral. These products are our main ones. So far, this is the core of orthofix. They are put around the leg of the patient, and they are sent inside through pins and wires. Probably you've seen that in a leg of a patient. It's a shock when you see the first time, but this is our life. Orthofix work with deformities correction every day. What happens? Why do I need an implant that will be in the medullary channel? Because I have this Not always. This is the most comfortable thing. Statically speaking, sometimes it's not acceptable to the patient, this kind of fixtures. So I have discomfort, not the pain, in fact. Uh, it's in fact when taking a bath, when wearing a outfit, you see the shock between the components, and mainly this thing here. Let me just try to play this one. This one here and this one here are the pins path. Here, it's delicate. In fact, the pins when are transported and the bone increase, they pass through muscles, anatomic regions which are delicate, and when they are removed, they generate skin granulation. It's a problem to a static problem to the patient in the end. This is an example. So there is the pin mark, and the skin is different when you have to put the pin inside the skin. You have the scar. A person that wants an implant, sometimes they have a severe problem. They don't care about that, but many people just want a simple deformation correction. They have their skin in the best aesthetical way as possible. So the most important for fit bone is I put a stem, minimum invasive one. The patient's not feeling pain, no implant passing through their muscles, skin, nerves. It adjusts, it's better adjusted in the elongation, moving the muscles forward, carrying all of that without having to reposition the pins. And aesthetically for them in their daily routine, you don't have this impact of looking to this implant in your leg every day. A little bit about the regulatory part. This is a system for intramedullary elongation for femur and tibia. And the prescription for patients over 12 years old. We had a problem when it was inserted, it was input in the system. We didn't have the information of adults. So this is a stem for pediatric patients over 12 years old. So when the doctor requested our stem and it arrived at the companies, at the insurance companies, they said, but this is not a pediatric patient, it's an adult. So the product became off-label because it was characterized as a pediatric product because of an error in translation. I'm from the technical part, but it was a loss of time. It was a big waste for us. Many contraindications, but they are the same for external fixators as well. The load for the patient, if the patient can work with this thing here, if there's a family member that can work with that in their daily routine, because it's made by the patient, the control. I didn't mention that, but all of that is made by the patient themselves. So all the elongation. This is like a key. This is like a screwdriver. And this is a system that you make a click on it. This is something weird, but the patient will have to do that. All of that is done by the patient in their homes. A little bit about the background of the stem. It started in 99. It was bought by Orthofix in 2020 to replace another system we used to have. And it's under development so far. It arrived in Brazil right now because the factory from 2020 with the pandemic, it was taken to Italy, was implanted in Italy, and all the records were made in this time period.
So this is the system, a control set, a transmitter, a receptor and a stem, and all the instrumentation. And the software, of course. The software is used for the surgical planning, for selecting the measurements, the positioning of the fragment, the size of the screws, the lengthening required, and all the surgical steps. All the physicians are trained. This is a STEM. We don't have any first comers here. All of our physicians are either trained abroad or locally by our consultants. So they learn about the software, and it's not a product like a trauma stem that can be used by everyone in the market. A little bit on the software now. We have a quick video. So the software provides the physician with all the information. All they have to bring us is an X-ray, and we have a team supporting physicians during their surgical planning. So they do the measurements, they find the anatomical and mechanical axis, all the joints, the angles. They select the implant, they select the axis and the size of the implant. The regulation of the fragment, what is the position of the axons, and the position of each of the screws. So it's a product with an embedded technology that physicians can use for surgical planning and for the procedure itself. The physician receives a report with all the data, and this is a system that's available online. They sign up in the system like they do in their email account. This is the 4th generation of the product, so it comes in different sizes. We have both for adult and pediatric patients. There's a better connection between the receptor and the stem. It's water resistance because it is subcutaneous. The receptor is better water tightness now. So this is the system that thinks about the drilling for doing a reverse plan. When you do a reverse plan, at the same time you are placing the stem, you also correct the deformity. And as the stem is lengthened, imagine that I have a gap here. As it elongates, it also corrects any deformity on the leg. Because if I elongate a deformity, because the femur has this anatomical axis, the knee will turn inwards more and more. If I don't correct the deformity, the patient might end the process in the wrong position. So this lengthening will correct the deformity as well. And this is called reverse planning method. Several published papers, and our softwares are based on this technique. Another important thing to mention, in the end, it seems like there is a gap here. However, that 1 millimeter a day that patients do, we have bone tissue being generated here. So the osteocytes continue to pass here, and at the end of the lengthening process, after 60, 80 days, depending on the time needed, we have bone growth. So there's no need for grafting. So the bone of the patient will cause the lengthening. It's almost like a fracture here. It will ossify and the bone will basically regrow. So there's no need for grafting here. There's no need of any biological material. The osteocytes will fill this gap. This is an example from the stem. This is the creation of the regeneration. And at the end of the treatment, we see the better balance between limbs, and again, no deformities. What is our next step in terms of registration? this is Vanessa's responsibility, is our bone transport stem. I'm going to pretty much get a fragment from the upper part. I will connect here and I'll bring one bone fragment from one position to the other for major bone losses. It's not just lengthening, we are literally transporting a bone fragment. If you have any questions, I'm available. Congratulations. I was quite excited to ask you a couple of questions, but you talked about the training already. You send physicians abroad. But you mentioned that you have been using the system since 2019. What about the clinical research? How did you do that? We acquired this technology from a company called Winstein, and they have developed this back in 1999. The product is owned by a physician, Dr. Haugart. So he would produce clinical papers on this. And again, we have other similar products from other companies, but he's producing scientific papers. And Orthofix also has a clinical studies department, which is responsible for the follow-up, for writing scientific papers. And they share with the marketing and sales team all the clinical information about the products. And all of our products, they really have a really robust level of evidence available online. Like any company, you need to monitor the patients and the use of the products in the market. So perhaps it would be interesting to understand the number of patients that have already been treated with the device and the images showing the repairs that you were able to achieve. I didn't add that to the presentation because I didn't know the audience. Because again, when you're talking to physicians, you can show more graphic images of surgeries. But when you're talking to non-physicians, some people might get a little bit sensitive when seeing surgical images. Do you have an idea on the number of patients that have received the system? Only in Germany, since 1989, we did 140 cases a year in an institution that would be equivalent to our public healthcare system. So 140 cases a year since 1999. So we have a really long case series. Even in Brazil, there was a previous stem called SKD used a different type of technology. And in Brazil, we would do about 20, 30 procedures a year, because this was a specific product to be used by specific physicians and a very specific technique. So it was a product that required physical therapy for the lengthening. We didn't have this servo motor technology. So it required a slightly different approach to the treatment. This is different. In Brazil, we launched this product in the beginning of the year, and 5 cases have already been done. And another question, what's the average treatment time? Like I mentioned before, 4 to 8 millimeters. Yes, we have 3 options, 4, 6, and 8 millimeters. 4 centimeters, 1 millimeter a day, 40 days. 60 days for 6, and 80 days for the 8 centimeters for the lengthening. And then you have a consolidation period. So usually we double that time. So it's quite a long treatment. But in our market, this is common. Once the treatment is finalized, that internal sensor, the receptor, is it removed? Well, the idea is to explant the whole thing. We remove the cable, so there's another procedure for the explantation. Because when you're talking about intramedullary stems for elderly patients, usually we are a little bit more careful in removing them. But for younger patients, the explantation is recommended so you don't have any other issue maybe associated with an accident, for example. So we're going to open for the audience now. Hello, my name is Rafael from Metro. Congratulations on the presentation and the product. I have a question about infection. Is this common? It is common in implants. In the case of an infection during the procedure, can you replace it for a revision stem? Thank you for your question first. Like any other type of implant, usually during the surgical planning, we always develop a plan B. So sometimes, not only because of an infection or any other incident with the stem, we can also position another implant, like an external fixator or just another intramedullary stem. For example, if the patient has a more severe osteotomy, there's always a plan B. Intramedullary stems, even external fixators, when there is this pressure, the communication between the outer exterior and the inner environment, the case series for infection is very similar for different types of implants. Sometimes it's even lower comparison to plates and screws because the exposure is limited. But the case series for infection is quite similar between them. What about the material? Hi, I'm here. Lucio. Hi, I'm here. Which is the material used? And during the development, what type of alloys did you test? And which was selected for the product? I was doing something else during the presentation, so I might have missed this. The stem, can it be removed? And if yes, how much longer after the procedure or the treatment? Your two questions are connected. Because this is an implant made in stainless steel, we developed it in stainless steel because we're going to remove it. Titanium leads to a better osteointegration, so the organism will create a thicker layer of bone around the implant, so removal will be more difficult. So that for that reason, we make this product in stainless steel, surgical grade, of course. So we never considered doing it with other material. I think one of our competitors do it in titanium, but our product has always been made with stainless steel. I'm just curious, is this, well, oh, which department in ANVISA regulated this? I imagine it wasn't JKP because I have never seen this before, but I imagine it required a joint analysis. Actually, she's the one supporting me here. This again, this device stays with the patient. You can just give it to the patient, and after the procedure, you teach them to use the device, and they come back to another visit. There's sort of a latency period before you start the lengthening, and again, the patient takes this home with them. This comes in sterilized packaging inside the OR and will be implanted with the remaining sterilized instruments. So I think pharmacy, CMA, CMO, and all the rest. Good morning. Here. I'm also curious, does this system have any type of safety feature if the patient or the user wants to go beyond the recommended limit during therapy? For example, I want the therapy to go faster. So is there a safety feature preventing patients from doing that? These products are not access proved. So in our market, the X-ray control is done weekly. Every week, the patient goes to the hospital for all types of lengthening methods. And we do an X-ray control because we look at the bone regeneration, the lengthening that took place, and we check if the patient is adhering to the treatment. And if that doesn't work, we have a similar control set on our side with a slightly bigger emitter to retract the stem. So if the physician notices that the patient is overdoing it, the physician carries a control set so they can manage that. And they retract the stem and you close that fragment. These are the safety measurements we have. All the other controls are associated with the patient follow-up. That's why this is not a widely used product. We focus on some very specific physicians because it does require a very close follow-up. Physicians understand immediately if the patient went beyond the limit or this is only noticed after the weekly appointment. They do an X-ray control, and in the software, there's a ruler for measuring the lengthening. And they look at the bone growth. And again, sometimes the patients might be doing everything correctly, but the body is not reacting accordingly. And then they decrease frequency. Instead of doing 3 times a day, they do it twice a day. Or they can increase the frequency because the bone is growing and the consolidation will happen quite fast. So they do 1 more pulse a day. So they manage that. And that's a great question. It's very important to have the physicians in control here. Because again, in our market, they really prepare the patients in a differentiated way. Patients are constantly in the office. Once I heard from a physician, I sometimes get birthday presents, Christmas presents from the patients because it is truly a journey. We're talking about 1, perhaps 2 years of treatment, for the patient. Any other questions? Anyone else? So thank you, Lucio. Thank you so much. And of course, our official picture now.
Enquanto eles posam,
So while we get the picture, we are announcing our lunch break. We will be back at 2 p.m. sharp. Thank you so much.
muito bem, muito boa tarde a todas e
Good afternoon, everyone. We are moving forward with the 5th edition of the International Seminar of Medical Devices ABRAIDI ANVISA. Now we'll talk about AI in surgical support for robotic surgery, the user perspective. Dr. Renat Sabatini, founder and former president of SBS and Agile Institute. He will be with us from Campinas. He is online, he is remotely talking to us. Good afternoon, Professor. Can you hear us well? Let's just check the sound with the professor. Luciana Machado, coordinator of nursing post-graduation in Albert Einstein Hospital. Welcome. And Dr. Bruno Figueiredo Miller, medical manager of surgery in Albert Einstein Hospital. Welcome. And again, the guidance on the microphone, just be careful. The floor is yours.
Muito bem. Bom, boa tarde.
Good afternoon, everyone. It's a pleasure to be here with you, even though it's virtually. I would like to be on site with you all, but it was not possible for me. But I really wanted to accept this honor of that my colleague Sergio Madeira invited me to be part of this Congress of ABRAIDI ANVISA. And I think the theme we'll be discussing here today is really interesting because a lot of people is not aware that AI can be applied to surgery as well. Many people think it can be used for diagnosis, prognosis, on the guidance on the patient's behavior, but the applications of AI in surgery and in other procedures turn to intervention in the patients, they are rare and most recent. So AI evolved quickly in the support to surgeries, and the event today will show you experience from two presenters from Albert Einstein Hospital. They were announced here, and I will shortly introduce them. Luciana Machado and Dr. Figueiredo Miller. And AI in robotic surgery is something transformative in health. It offers more accuracy, more safety, better results. And as the technologies are evolving, they are almost in the first steps. And for sure, there will be a huge impact of these technologies on the surgery, mainly robotic surgery, which is instruments with high technology. In reality, this is equipment that is tele-guided by a human being. So the human being, the doctor, nursing, they are really important in the point of view of the performance of the surgery. However, AI starts to show certain autonomy. Maybe in the future, robotic surgery will be totally commanded by AI. Will it be an autonomous surgery or only small details or interventions like higher increase of accuracy on manual handling of the surgeon in reduced spaces, for example, an operation in a medical ear? Recently talked about on robotic surgery and AI in modern surgery, the integration have been brought many improvements. This study showed that robotic surgery in AI has 25% in the time of the surgery, 30% in intraoperative complications, 40% in surgical accuracy, and 15% less time of recovery for the patient. And also, the improvements decrease the incidence of infections, loss of blood, and also increasing 20% the efficiency of the working flow of the surgeon, leading to a reduction of 10%. We have a technological wonder, like it's a goal in health, increasing accuracy and the outcomes, improving the situation of everybody, patients, doctors, and increase coverage. Today we'll hear more about that, and we'll have some time for for questions from the audience, also the remote audience, for these two big names of robotic surgery in Brazil. Luciana Machado, she's a she has a nurse from Albert Einstein College. She has a lato sensu degree in in health management and executive managing in health also for the same college. And she is post-graduation coordinator, a new post-graduation course in nursing and robotic surgery from Albert Einstein School. Welcome, Luciana, here to our event. And let's hear you. The floor is yours. Second is Dr. Bruno Figueiredo Miller, doctor surgeon graduated by University of São Paulo, robotic surgery by Albert Einstein School as well, hospital administration by FGV, and the Formation and Perfectioning Center in Science and Health from Hospital das Clínicas from the University of São Paulo. And he also works in the Einstein's incubator in the Entrepreneurship and Innovation in Health program, medical manager in surgery in Albert Einstein Hospital. He's also a consultant in robotic surgery. Two people with more than 1 decade in expertise in this area, and we are looking forward to hear from you. Thank you, and please, Luciana, the floor is yours. Thank you, Renato. I would like to thank the invitation from Medtronic, Dr. Sergio. I will start talking a little bit on the user perspective, but for such, I'll just put into context Einstein Hospital and where we are with robotics there today. Einstein is the 22nd best hospital in the world. In the last 6 years, we are within the best hospitals in the world. And in Latin America, we are the first, number one. As you can see, among the strategical pillars of Einstein, there is the inclusion of innovation. Einstein is always looking for innovation. It also engages AI, new technologies, and so on. Our volumes today, in the last year, we did more than 73,000 surgeries. We are managing private and public hospitals. The numbers are summed to in both areas. We have more than 94 surgical rooms around the country, more than 590,000 patients served in the last year, more than 60 units. In robotics, since 2023, we have orthopedics, column surgery as well, and we started in 2008. We have all the expertise, digestion, cardiac, thoracic surgery, gynecology, oncology, pediatrics, and urology. Today we have robots in 4 units of Einstein, one in Morumbi, the first main one in São Paulo, a private unit, and we have there 3XY, 1X, and 1 Hugo soft tissue robots, 2 robots, Mako and Rosa for arthroplasties, and Mazor for column surgery. 11 simulators dedicated to the training of our surgeons and surgeons from Latin America. We have a unity in Goiânia, also private one, with 1 XI allocated back there. Santa Catarina, and in São Paulo, a municipal hospital with oncological focus 1X. And in CTEC, our training unit 1X, 1XEI. Since Einstein is bringing AI, how Einstein is bringing AI and how we live this experience there today. We have courses about that. I brought some subjects showing what we've been done regarding assistance. We have QI Nova Einstein, King Nova Einstein for employees. The clinical body can bring ideas on the improvement, on the assistance involving everything related to innovation. And inside the projects received, many times there is AI in health. Here, my role is not talking about the technique, but basically AI are computational systems able to perform tasks that normally would require human intelligence. So there are some models, patterns recognition, written image, logical ratio, and autonomous decision making. And how can AI help nursing? There are many works telling AI for nursing it would be a support. It supports the nursing area decision. Many times today, AI is not making the decision. The decision is on the nurse or the doctor or from the assistential area. These are some examples we have, and one of them inside Einstein that's being really interesting and widespread is the use of data in AI to prevent the aggravation of hospitalized patients. We have a center of assistential monitoring, the picture you have on screen, and we follow patients' data from the surgical center, hospitalization unit. The data are on record and they are followed. And some triggers were created that call the team. In our surgical center, we have cameras. If one of the triggers, for example, the patient is in the record that it has hypoglycemia inside the operational room, this area will call the nurse to understand what is happening. So the patient's parameters are followed in all the units and also in robotic surgery. This is a big differential that helps nursing to pay attention to things that and complications that may be happening. These are other examples. In clinical, we have surgical checklists, surgical scheduling, post-op follow-up, inventory. I have a model here, the template. Today we are following the robot. We can do that with the AIUs, with the clamps, the clips, or the forceps from the robot. Many times we need to ask more. Also, sometimes we have to import things. So the planning of the inputs in robotics have to be previously made. In surgical scheduling, there's an optimizer. It's going to follow the history of this surgery. Sometimes you have a robotic bariatric surgery. How long will it take? Will it last? So during the scheduling process, the data of all the surgeons are followed. It's in the system, and they know certain surgeon will spend 3 hours in a room, another one 3.5 hours, so they can fit the surgical slots according to each professional, and not only what used to be. It was equal to anyone, and it will cause delays and impact on the patient's flow. Another thing that AI helps us a lot is patients follow up, post-op, and after 30 days, 7 and 30 days, the infection is measured. The risk of infection is measured. So the patient fill the form, also bringing triggers, many operated patients. And before that, we were looking to them one by one. Now the patients that answered to a question or made a comment in this questionnaire, which would be a warning that they are developing an infection. And with that, we are able to bring the patient to the doctor or the nurse to be assessed and occasionally providing a clinical treatment so they will not have complications related to that matter. This is a paper about text mining performed in big database. This is patient's experience after colorectal cancer treatment. More than 20,000 patients, more than 218,000 patients. This is made one by one, would be a long process. They can collect and separate the patients, the one with positive experience, how it's self-care, if they had a negative experience. And with this filter, we could call the patients and understand better what is happening to them. Another important thing in robotics is training. So since 2022, we have the regulation of CFM to form surgeons, and they have to spend 20 hours in the simulator with us. These 20 hours are standardized today. All the surgeons are doing the same exercises, and the idea for the future, and it's being already developed, each surgeon can have a gap. So maybe you need more exercises related to the field or another one with stitching. And how can we customize and understand what the doctor needs to work more on? It's arriving right now, soon, I think. Another thing I think is encouraging the formation or the engagement of nurses in technology is with events. We have Nurseathon, an event dedicated to nursing solutions where we are bringing people from tech areas, health managers, innovation professionals to think about the same problem. In this case, it would be the workload, assistential workload. The last editions, we had many suggestions related to AI for the work scale of the nurse or to replace the report that sometimes it takes a while. So it's a way to everybody to think together about the same problem. And something that is always a question, will AI take our jobs? I think not, at least in the health area. It's a low risk, as we can see in this paper from Microsoft. We have professions that can be clearly and are that are clearly being dominated by AI, but in case of nurses, assistant surgeons, as we can see, it's not the case here. COFAN and CORAIN, the regulatory bodies of nursing, they have the same opinion on this matter, which is essential to nursing. We support on the processes, but it's not replacing human care. I brought a report from Future of Jobs from 2025. This year, they are serving with leadership, experts in technology, and the idea is foresee each professions will grow based on AI, based on the possible automation level for that profession. If it needs a lot of human interaction, clinical judgment, and empathy, it's harder for AI to take that job. And repetitive and predictable tasks, this will be easier. So I brought also here how jobs in 2025 and 2030 will increase the search for nurses. But in counterpart, what we see, since we have a lot of AI in the daily routine of the nurses, the formation of the training of this team would be a more interdisciplinary one. They will need a knowledge in AI, information technology, digital ethics, data interpretation, but the repetitive task will be reduced, the ones that take a lot of time in their routine. And with that, we are able to focus more the care on the patient, direct to the patient.
And what are the current limitations we have today? Lack of universal data, anatomical differences because patients are very different. What works for one might not work for the other. The need of constant oversight. In our hospital, we have some AI systems, for example, for preventing falls, but we still need the oversight of the care team. So how can we validate the algorithms for clinical use? We still need more robust clinical studies. And of course, there's a risk of overly trusting AI and professionals perhaps losing focus. Access is another important topic, even though we have seen a growth in the number of platforms installed in Brazil. We know that both AI and robotics are mostly located in large centers, and there's a lot of inequality when it comes to professional training, and this is definitely a barrier to be overcome. Thank you, Luciana. Good afternoon, everyone. As a surgeon, now I'll talk more about the practical aspects. Luciana mentioned quite well how AI is influencing the dynamics of the hospital, and somehow that has to do with what we do as surgeons on a daily basis. But now I will discuss the clinical aspects and the clinical use of the robots and how AI is being used to support that. Just to get us started, how do non-surgeons perceive surgical procedures and surgeons? The perspective from patients, the payers, our fellow physicians. Whatever happens in the OR has always been perceived as a black box. It has always been very difficult to understand what happens during a surgery. And with video laparoscopy, we started changing that. And with robotics, we promoted even more information sharing from the OR. But AI and this new layer of information that we now bring when we start using AI require us to open this black box. And as I'm going to try to show you, we are seeing safety, efficiency, and operational dynamics with the use of algorithms, which was impossible to do before when we were by the bedside with an open chest operating on the patient. Now we have other data to help us with that. So in a very simple way, I have divided a surgical procedure into the pre-op, peri-op, and post-op moments. Luciana already described what we do to follow patients in the post-op moment, but especially pre-op. I have a quick video illustrating our app. It's called Einstein Medicos. As you can see on the right hand or the left hand side, we have an algorithm called AI Story. Every time we access a patient's electronic medical record, we can click on AI Story and talk to an AI bot about that medical record. Of course, this is a closed AI algorithm. We don't have any external information here, but we can talk to the AI, especially for very complex patients with a long medical history. As you can see in the video, we can talk to the patient's electronic medical record to understand previous treatments, what are the current diagnoses that they carry, if the patient had any complications before, any allergies that might have gotten lost in their EMR. A lot is said about this, but when you look at the thing actually happening, it becomes quite clear what a game changer this is for care. I don't know how many physicians are with us today, but every physician who has seen a patient arriving with a pile of test results understands how an algorithm like this helps us and how much it enables us to do a better diagnosis, because sometimes we lack the human ability of doing the right diagnosis because we simply don't have the time to read all the information in the EMR. So this is a very powerful tool for the pre-op moment. It's already working. It's a partnership with Microsoft, and it's running inside our app and in our clinical EMR. Still on the pre-op moment, of course, we have to talk about decision support. This is a comparison on the decision-making for the treatment of colorectal cancer, comparing Watson and oncology experts. And in the results, this was an observational prospective trial, and you can see a very high level of agreement for decisions about colorectal cancer treatment. Regardless of the clinical stage, of course, there's a small variation, but the results were quite satisfactory when we are talking about the understanding of the functionality of the system and the safety, perhaps starting to debunk the myth that we cannot trust AI or what could happen. Of course, we still need to improve these models, but when we start seeing results like this, it's very exciting, even with the little experience we have with AI, and this is certainly very motivating for those who are enthusiasts for the technology. And just like case assessments, we can do the same for predicting risks. So trying to predict complications, the need or the lack of need for potentially surgical conditions. So once again, we have different successful case in the pre-op assessment and in the risk assessment of patients. This is not necessarily new. This has been going on for a couple of years, but as we see the growing enthusiasm on the matter, all these results become more common and for more pathologies. Of course, because of my background, I will show you a lot of examples connected to GI tract diseases and colorectal cancer, but we see that the same examples can be found in different medical specialties. Here, it's the prediction of surgical complications with the use of AI. Because again, we have a lot of data available on our patients today because video-assisted surgery gave us the video and robotics gave us not only the video, but actually an understanding on how the physicians actually does the procedure. We have a mapping of all that. I think there's a video here. This is just one model to capture images. So how we capture the movements of the surgeon and how we can mix that with a computational vision. We know that an AI layer here is being added in order to identify anatomical structures so we have a better understanding of the risks and the anatomy itself. And that allows us to do not only a risk assessment, but a performance assessment. So we can give the feedback to surgeons either in a learning curve or if they're experts, what are the opportunities for improvement that were identified? So we can identify those possibilities. And now we are in the perioperative moment. So we're going from before the surgery and now we're during the procedure. And in the videos, we can see in this 2022 publication, these are models that try to identify the anatomy and tell us or help us identify what is safe, what is not safe, what are the anatomical structures that we should approach, or the areas where it is safe to navigate. On your left-hand side, we see a simpler version. We would mark our dissection plan, and it will give us the better areas for the dissection. And this is a second model on the right-hand side that was presented in Strasbourg in France in the SRS conference. Can someone push play? Thank you. So in the image, you can already see the safest intervention site. So this flashing green light that is on the screen is exactly the site of the dissection. And this is done by an AI algorithm. It was published in this study, and it's a technique that can be replicated. Obviously, this is not commercially available yet, but it only increases the level of safety. Again, I don't know how many surgeons are with us today, but if you had to treat a difficult biliary duct, which can be quite a simple procedure, it knows how much this can help in a very complex case or in the face of any challenging scenario. So companies start now to have more information. We can assess the image, we can process the image with AI. And of course, different players in the market now want to give all this information back to us. This is one proposed solution. It was pretty much a tablet that you could put either on your video tower, in your robotic console. And for any intervention, you could pretty much position the tablet, and it captures all the images. And the images are processed in their ecosystem by an AI system and by peer review, and they give feedback to surgeons. So there's a website. You can watch your procedures. An AI tool separates the different steps in the surgery. This is the anatomical identification, this is the dissection, you're removing the specimen, this is the suture, and comparing with your global peers, your performance is at 70% or 50%. How do you compare with your peers in the world? And once again, you have an opportunity for improvement. It's not that my surgery is bad. Maybe I need to improve my suture technique when I go from right to left. And I don't need to necessarily improve the whole procedure. In the past, we used to believe that we had good and bad surgeons, and the nurses usually knew which were which. And today we have data, and more than knowing who are the bad surgeons, we can help everyone. We can show them which areas need to be improved. This is another video showing another prediction model to try to discover what's under the black box. It's an algorithm that films the whole OR, similar to what Luciana mentioned about monitoring. And the algorithm tries to understand what is happening in the OR. What is that specific surgical time? What is happening at that point in time to try to predict not only unusual movements, but also safety issues, a situation that might suggest we are approaching a critical moment. Why is the nurse running from side to side while the physicians are operating? Is something happening? We do this manually, of course. We have a trained team that observes the surgery, but now we're training an AI. This is not a technology from our hospital, but it's a model that tries to do exactly that, but with the use of AI. It recognizes people and their interactions. Just a minute. This is another model for collecting the same type of information. This is a different solution. We are doing a beta test for this solution in the market. It's not available yet. We're helping develop it. So it captures images both from the procedure and from the OR. All these images are taken to a platform, and our idea is to get insights. Of course, from an academic perspective, this is a surgery for training. Dr. Sergio Araújo, I'm sure you know him. He was preparing to use this robotic platform for the first time in a GI surgery. We do a dry run without a patient, and then we use the platform to first do a training model or a dry run so we can understand the dynamics in the room, and then we replicated the same thing with the patient, which is the image that you see here in the bottom. So the same training that was done before was then replicated, and we used that to ensure the safety of the procedure. And this was the first colorectal procedure using this robotic platform done in Brazil. Now, we're coming closer to being autonomous. I'm a little bit more skeptical. I'm not sure if we're not going to be replaced. Maybe we'll be replaced last. And I'll try to explain a little bit why I believe in that. We have several studies that were published, even about FDA-approved platforms, talking about the level of autonomy that they can have. Today, we classify them from 0 to 5, from no autonomy until fully autonomous, to the point that there's no medical intervention necessary. The level of autonomies we have today are 0, as mentioned by Professor Renato in the beginning. The robot does not do anything by themselves today. We need to do everything. Quite soon, we're going to have a task autonomy, We know that we have robots that are being empowered with AI to help us make decisions and to make some decisions for us and perform some simpler tasks. But we already have some robotic platforms with a high level of autonomy, especially for simpler tasks, of course, but they do have the autonomy, so they can plan, execute, and pretty much do the whole thing with supervision, so always with someone watching. This is just a summary. Many of these things were already mentioned before, but these are important characteristics of autonomy and why it needs to be improved, because it works where humans have limitations. So precision is one thing. Improved precisions and movement predictability. How can we inadvertently cause an injury? So how can the robot prevent that before you cause harm to a structure? Also time savings and the improved safety for the patients as well. Likewise, the recognition of peri-op tissues and the surgical guide. So how can we face anatomy in a simpler way and perhaps deal with the surgical conditions and the different types of anatomy? The interpretation of the anatomy during the procedure is very important, and surgical navigation can certainly help with that. Sutures, which are surgical times that are very similar, how we can optimize that through AI. And in a minute, you will see that we already use AI to do that, to optimize these surgical times with AI to improve time use and precision. And finally, surgical planning. The idea here is to have a more efficient approach, a more efficient technique through a planning that was done by an algorithm that has observed 100,000 surgeries and compared to one's individual experience that can be quite limited. Autonomous robotic surgery now. These are some examples of platforms that already carry some level of autonomy. The first one, called T Solution 1, this is an orthopedic solution that does surgical planning. So based on the tests, we have a surgical plan, and the platform helps the surgeon to perform the bone insections and the bone resection without room for error in a guided fashion. We have Artas. I don't know if you are familiar with this, but this is a hair implant platform. This is something that is growing in Brazil just recently, but it has been a reality abroad for longer. This is an autonomous platform. It requires supervision, but it's pretty much autonomous. And it can capture the hair follicle in an automated way. It maps the scalp, and using the Fouet method, it captures the follicles, only the good ones, because it can differentiate good follicles from bad ones. And after that, it also implants the different hair follicles. So it captures the follicles, select them, and then redistribute the hair follicles to do the hair implant.
VBot is a platform that does venous function, also autonomous one. As far as I know, it's not in the market yet, but it also autonomous one. It does the mapping of the vein and the function of the vein by itself. And Cyberknife is radiotherapy platform, a platform that can adjust the distribution of radiotherapy to the patient despite the position and the physical complexion of the patient. And we can properly distribute therapy, even more when we need higher doses. The ones that need a more intense treatment, we are able to distribute to better the dose versus a disease. If you have radiotherapist, I'm sorry if I'm saying totally something wrong, but this is the information we have on this platform, okay? Moving forward about autonomous robotic surgery 2022, we have autonomy enteroanastomosis in an in vivo model Persino. In laparoscopy in tooling, there is the report of cases. You can see 4 cases versus control. We have a higher time, but survival of all the porcine models, the majority of them get some weight. When they lose weight, it's a little bit. The surgical time is higher for a robotic platform, but it's showing some success in here. And recently, maximum level of autonomous surgery. Everybody saw in social media, everybody that is researching on health. This is all over social media. Hopkins model. They perform 6 or 7 surgeries, if I'm not wrong, cholecystectomies in ex vivo porcine model. They were telling it was human autonomous surgery. Fake news. No. This is hierarchy models of AI. Some AIs working with hierarchies, some interpreting imaging, others planning the forceps movement, and they operated 6 or 7 porcine models, totally autonomous task. One important thing here and an interesting thing is the robot learning by seeing cholecystectomy. They saw the path of the movement. They saw the robot from these 6,000 cholecystectomies. Despite the anatomical differences from one porcine model to the other, the robot could correct itself 6 times per surgery. It was more accurate than the control. For that, they have more smoother movements than the expert, and it was classified with autonomy level 4. I told you before, it understands, makes decisions, and does the procedure, but they need a technical surveillance. This is a little bit about what I said about this model. The robot compared to the surgeon, and you can see here, it ends up with speed of movement a little lower, but at the same time, they get in other aspects. Mainly in the point of view of the path, the trajectory point of view. On the movement, it makes less movements. They lose in the time point of view. The surgeon is faster, but they are more economic, probably in tissue traumatization, and for the ones in the more complex surgeries. You know how local trauma is important when we talk about surgery. And this is a provocation that is already being made, but Lou told us a little bit about that. Medical, legal accountability involved in this autonomy. Who is in charge of the error? The manufacturer, the coder, the surgeon who was not there. But so we need legal landmarks to approach that. This QR code is editorial from Stanford, and they start the discussion on who to blame. And who to blame when AI makes a mistake in health. Obviously, they approach in a wider point of views, not so specific for surgery. This is a discussion we will have to make. This is something we will have to mature because nobody asked the pilot of the Boeing we are flew in when they left the plane in autopilot or not. We just got used to autopilot. It's something, it's about getting comfortable with technology. It will not be different with that one. When we need specific technical parameters so people will be comfortable with them. Take-home messages. AI interaction and robotic interaction is here to stay. The ones that are dealing with robots, manufacturing robots, or thinking about interacting with robots, you always think about AI coupled to the technology. It's really hard to separate. Like in nursing, it would be a reality we'll have to deal with that. The scope of robotic surgery will grow probably. When I showed you autonomous robots, almost nobody used to think about that for hair implants. And if they're doing this by themselves, why not? So tasks which were simple ones or maybe too hard for a robot is each time getting more friendly as we have the intelligent interface in the middle of it. Health professionals need to be trained and prepared for higher levels of interaction with technology. What I mean by that is we are discussing how we're going to deal with that, but the doctors we are graduating, how will we train them? We don't have the dimension or the correct appropriation on to what they will need to be trained to practice in surgery or in medicine, the role of a surgeon in the future to deal with these technologies. How are we preparing ourselves to put surgeons in the market that will deal with autonomous or almost autonomous robots? We need to talk about that. And also we need to guarantee the access. We talk a lot about the cost of robotic surgery, but each time more, the message on what we're being able to save because of it probably will save in another layer of autonomy. And each time it will before and then people countries will have more access to robot surgery. At Einstein we bring an example that is closer to us, how much investing in medical education in robotics itself made the technology to be all over the country. We had since the pandemic a big role in training, and we saw how much surgeons are comfortable and how much they like now technology. More than 150 platforms all over the country. A lot of people discussing the use of AI now. And I think AI is here to make the surgeons to do better surgeries, more surgeries, but also in a most effective way. This is what I had to tell you. These are our contacts. Thank you. Professor Renato, we cannot hear you. Just a minute. Okay. Thank you for the excellent presentations you made. I learned a lot today, like everybody present here. And we have many questions to make because I think, as Bruno and Luciana said, this is a future that this is a future. There's no turning back here. When we started talking about this discussion, there was a skepticism on if it was really a real progress in surgery, in all their parameters dealt here, like patient safety, shortening of the surgical time, decrease in errors. In summary, our goal of being patient-centered, but robotic surgery is now strong, mainly through the equipments launched in the market now. And although it's a expensive solution for the most of hospitals, or maybe too expensive, in fact, it was embraced with a lot of enthusiasm. An application that I could follow was on retroperitoneal biopsy. It's something really hard because some lymph nodes increased ones between the aorta and the cava. It was really dangerous. This is something that before it was like in a blind path. We need to open the patient, locate the nodes. It was a hard work. And now with robotic surgery, it's almost a routine procedure, low risk procedure for a patient, depending on the skill of the surgeon, of course. And something interesting, Bruno, that you said is autonomous surgery can be made by distance. So we have examples of robotic telesurgery. Recently, there was one in the news in the outlets, a surgeon in Asia and patient in US. And even with the delay regarding feedback between the view and the action, the use of 5G technology and optic fiber, high-speed optic fiber, could reduce the delay to the point the surgeon had no problems with that. And NASA is funding a big study to use this in a trip to Mars, because the delay is so big that it's impossible to apply in real time with a surgeon based on Earth and a patient with 20 minutes in delay, 40 minutes, in fact. So a robot on board able to do autonomous surgery, since there will be no doctor on board with the crew. This is a solution they are thinking about. A patient had appendicitis in full flight when arriving to Mars, and they will have to go to surgery. And another thing is the surgery with lack of gravity. Maybe you, the young ones, Einstein can create a project with NASA, and you can go to the International Space Station to make a surgery in a patient using the Da Vinci robot or a lighter, a simpler one. We have some time for questions. I would like to make an initial question here for both of you. We'll have a time for the remote and on-site audience. Question is, every time you have AI, it gets closer to a natural intelligence where error is part of process. There's no natural intelligence that is totally exempt of mistakes, of making mistakes. The medical ethics has a special way of dealing with error, negligence, and it will be applied to operators and AI. This is a question. In fact, you, Bruno, and Laura, you made this question. Who is the one to blame? The robot, the company that created the robot, the institution, and so on. We don't know how to solve that. We don't have answer to that question, but we'll need that answer. So the question is on the error by AI. Many people call it hallucinations. How do you see the impact of a possible hallucination, and how can it be prevented or mitigated through everything that you showed us, also including the works that measure the accuracy, sensitiveness, the error in a large number of parameters. How do you see that in the point of view of the future for the market? AI coupled to robotic surgery in equipments already in the market. Professor, thank you for your comments. I think one thing regarding space surgery, there's a robotic platform called Mira. FDA is approved for hysterectomy and colectomy in US. They did experimental procedure in the International Space Station. They did a procedure back there. It's a miniature robot, a small one. It's nice to take a look, but it's already happening. About ethical point, I think it's really hard to understand how will we, the way we're going to overcome error for someone we cannot name. AI in surgery or the autonomous robot, the understanding on technology need to progress. So as long as, I think that as long as the speech is man versus machine, we will always struggle to deal with the machine's error. As long as we are understanding, and training is the key here, the big advantage of language models, AI models, the training can be the way we want. We can stress out the AI the most we want. in training, and this will be the way for preventing error, but we'll have to deal with that because it's going to happen. Telling we're going to reach a point where there will be no error, I think this is the way for having trouble. We need to understand, as the professor said, the intelligence make mistakes. So AI will also make mistakes. What we need is paths for minimum error until a point that it will be comfortable. At the point you don't question the pilot why the airplane is in autopilot. And when this happens, it will be a part of, so far it's something that we cannot avoid anymore, but the surgeon is not the one to blame. We're training a surgeon and they can make a mistake. And as you said, we have this understandable way of analyzing the error, why it happened, and we're going to develop the same for AI. This is a point of view, Professor, but I think this is the most reasonable way of analyzing the growth on this capability of this intelligence, which is not our intelligence. There's a question from the audience. Emilene is the one. She wants to make a question. Good afternoon. How are you? This is Emilene from Intuitive. I thank you all for being here and presenting such important theme for all of us. My question for both of you, each one of you in your context, Dr. Bruno, many of the tools you presented, AI tools, we see them as a monitoring or general improvement for all the branches where AI is being used, like processes improvement, error improvement, time reduction, cost reductions, and leaving apart all these general ones from all areas. What improvements you can effectively see on the implementation of AI in robotic surgery? Thank you for your question. We have a well-assembled framework for having AI in almost everything today. The places where we effectively have AI working in our routine is really restrained. It's not much, but the improvement of the report, as I showed you in the beginning. As a doctor with 20 years of experience, to me, this is a disruption. Having any information I want from the patient in the record in just one question, in just one conversation. We were joking about that. Have you started talking to ChatGPT? Because I started to talk to my ChatGPT. It's easy to have the information to make the decision. This is a big impact. You talked about operational tasks. We occupied a lot AI with the task we don't want to do. This was the first moment with it, maybe. Now we have the opportunity of effectively having the task being performed by the AI. In robotic surgery, in fact, my main expectation now is anatomic navigation. I think this is going to be the big disruption we're going to see coupled to robotic surgery and AI.
Year after year, there is one plenary session in the Global Robotics Conference discussing AI. And what we see in a greater number of paper is researchers connected to navigation. Something else that we are studying in our hospital, so we can try to make this work with the use of AI, is the identification of foreign bodies in the image. This is a beta version. We're just getting started. We're still trying to figure this out. But in my opinion, right now, I see AI helping us with the safety of the robotic procedure, especially with the specialization of AI in imaging tests, differentiating tumors, understanding the different aspects of the tumor, if there is invasion on the surface or not, or if it's a malignous or not tumor in lay terms here. I think this type of interpretation can really count on the contribution of AI. I agree that for my area of work, safety is the most important component. Our surgical procedure today is 100% made by humans. So we are the ones checking the room, we check the equipment, all the devices. Like Bruno said, when it comes to identifying foreign bodies, it can be a needle or a gauze inside the patient's abdominal cavity. And all this work is done manually today. So I think AI can make a big difference in that. And another interesting thing is, for example, for orthopedics, when we do an orthopedic robotic surgery, the AI calculates the data based on the patient's MRI, on the patient's CT scan, and the algorithm can work with minimal medical intervention when it comes to the measurements that were taken. And we are developing a work in our hospital showing the little level of intervention that is needed. Many times we don't need to make a single adjustment in the measurements, and we compare that with the convention technique. Patients usually express less pain, the hospitalization time is shorter, so we can see those results in practice already as well. And just adding to what Professor Sergio said, we have an idea of the potential, but AI is at a level today that's completely different. We have a study to interpret the quality of the smoke coming from the electric scalp to help us identify if we're actually cutting or making an incision in the tumor or in healthy tissue. So perhaps a wavelength that we as humans cannot see, but that the AI can see. And maybe that could give us completely different information on perfusion, for example. So I think what is to come is quite exciting. But I am an enthusiast, so I am quite biased. I have a positive bias here. But even the dimension of what can be done with AI can actually change. I would have never thought about analyzing the smoke coming from the electric scalp to determine if I'm making an incision on a tumor or on healthy tissue. So I think there's no limit, basically, to what it can do. Quite nice. Can you guys hear me? Yes, we hear you fine. I would say that in many other areas, this type of functional imaging, because when you mention the smoke, it is a type of functional image. But I work in neurophysiology, and I was part of a large group of functional stereotatic neurosurgery. And with the use of MRI, you can identify functional areas, not anatomical areas, because the anatomy of the brain is quite messy. It's a big sponge. You cannot really see much there. But if you use functional imaging with different types of metabolic markers, either for water or hemoglobin, you can really identify the area that might need an intervention. And today, the stereotatic procedures are robotic. Even when we are inserting the probe, all the way to the area where we're making the intervention, whether it's coagulation or if we're injecting a specific substance. So it is fascinating to see that we already have stereotaxy robots using 3D images and using coordinates X, Y, zeta, or polar coordinates to identify the area with a precision of less than a millimeter. The area where you have that one small tumor that can only be identified in a PET-CT. And it's fascinating because we will be able to do surgeries quite earlier on. Surgeries at a moment that when tumors could not be identified by other tests. Well, unfortunately, we have come to the end of our discussion. We are actually 6 minutes late. And on behalf of the organizing committee, I would like to thank both Luciana and Bruno for their brilliant lectures today. And the topic will continue to be discussed in the next panel, session 5. So please stay tuned. And I hope you stay with us, Dr. Sabatini. Of course. Dr. Sabatini, we kindly ask you to stay with us for one more minute so we can take an official picture of this session. Our first afternoon session of the day. I apologize. I'm going to be a little bit bigger in the picture.
Muito obrigado aos nossos.
Thank you to our speakers. And now let's continue with our 5th panel discussion for those of us who are with us in the auditorium and with us online. The use of AI in the integration of complex systems, including the intuitive robotics. To moderate the discussion, I would like to call Francisco Iran Cartaxo Barbosa, an analyst at GQUIP from ANVISA, Brazil. Welcome. And our speaker will be Mr. Huai Li, Associate General Counsel working with intellectual property at Intuitive. Good afternoon. First of all, I have to thank ABRAIDI for the opportunity of discussing such an interesting topic for all of us. And without further ado, because time is short, I'll hand the floor to our speakers. So, Mr. Lee, the floor is yours.
Ali, por favor.
Thank you very much. Good afternoon, everyone. My name is Hua Li, and I'm the Associate General Counsel, Intellectual Property. So yes, I am a lawyer, but don't be alarmed. I'm an intellectual property lawyer, so nobody should be afraid. I'm just here to protect my company's intellectual property for the most part. But I also deal with all of Intuitive's innovations related to AI because I directly support the digital business unit. So here I am, and I have been sort of voluntold to be point person for everything related to digital innovations, including AI. But I want to thank ABRAIDI and ANVISA for inviting me to speak, and it's my pleasure to speak with you. I've heard very, very interesting discussions yesterday and today, and hopefully I can contribute to the conversation also. Okay, so before I begin, please note that some of the products, features, and technologies that I'll be describing are not yet available in Brazil, but we hope that it'll be soon. There are 3 areas I want to discuss with you today. First is the role of robotics in improving the surgical and diagnostic capabilities. And then second is how AI can unlock meaningful insights, right, and efficiencies to ultimately improve patient outcome. And lastly, and I think it's very important, we need to remember to balance the patient safety while promoting innovation. And that means we need partnerships with everybody involved, the healthcare system, the global regulatory bodies, and the surgeons, patients, everybody. We need to work together to make this happen. Okay, so there are a lot of hard problems to be solved in healthcare. And I can't get into all of them, but I want to describe some examples. In the United States, lung cancer is the most common cause of cancer-related death. However, if it's diagnosed early, it's quite treatable by surgery. So it's unfortunate that on average, it takes more than a year to diagnose the person with lung cancer. And because of this delay in diagnosis, unfortunately, up to 90% of those diagnosed with lung cancer pass away. Also, delay in diagnosing endometriosis is a well-known phenomenon, but still, there hasn't been a lot of progress in reducing that delay. And lastly, there was a recent study out of South Korea that looked into 1-year mortality rate after the mitral valve repair. And they found that for those centers that have low to medium, less than 40 surgeries per year, they tend to have much higher 1-year mortality rate. But yet, all of these problems and others, we're still working on solutions. So there's a lot of problems that Intuitive would like to contribute to solve forward so that patients then can receive the best healthcare possible. So we start with this vision that Intuitive has. We envision a future of care that's less invasive and profoundly better, right? So that patients can get back to what they really wanted to do. And our vision is anchored in our quintuple aim, which is our North Star. And if you have heard any discussions and presentations from Intuitive, we talk about this a lot, but we really mean this, right? So because the whole aim is to improve the clinical outcome. I don't think anybody can argue with that, right? And to enhance the experience of patients, but also the care team, because we believe if the care team has the best experience, it would also affect the experience of the patients, ultimately affecting the outcome for those patients. And then, of course, trying to reduce the overall cost of care and expand the access to the best quality of care possible to everyone. And that's what we are committed to in our quintuple aim, which is anchoring us in everything that we do. So for us, that means it starts with patients always. And I think everybody can agree with that. And I think a lot of the organization in the healthcare agrees with this. And we know that the products and services that Intuitive puts into the market really affect people's lives. So that means it requires high level of trust. And that trust means trusting Intuitive that whatever Intuitive does is trying to solve problems that are really important and relevant to our customers and their patients. And what that means to us is not just the technologies that goes into a high-performing robotic system, but also training and educating the next generation of surgeons and care team so they can make a positive impact on the efficiency, quality, and availability of the highest quality of care. So a little bit of, maybe a little bit of bragging, but a little bit of trying to see how much impact Intuitive has made. Last year in 2024, over 2.7 million procedures performed with Intuitive platforms. And 2025, we're poised to go over 3 million procedures. And that's over 16 million procedure lifetime with over 10,000 Da Vinci or related platforms around the globe that's been placed thus far. And it's not just those number of procedures and the platforms that were placed. There's been over 4,000 peer-reviewed articles on the positive impact of the Da Vinci system has had, and adding to the over 43,000 peer-reviewed articles that we have thus far to date. So when we are thinking about AI and how it's affecting complex robotic system, and I believe that was sort of the focus of talk, it starts with, based on what we think at Intuitive, it starts with foundation of data, right? And not just any data, but good quality data. Because that's the, if you don't have that foundation, your AI will not be as good. And what does it give you, right? So with the release of the most recent 5th generation Da Vinci platform, what we call DB5, again, sorry, it's not yet available in Brazil. It's enabling a lot more of the data streams that we can use for surgical computations, right? That starts with how the surgeons are controlling the instrument, robot instrument movements, but it also includes all of the extra data that Intuit is providing to enhance the vision for the surgeons, so that surgeons can see more, understand more, and do more than they could ever before. And some of the examples that we're working on, and we have currently available some of these, and to be released in the future, is tissue tracking and object detection, and fluorescence imaging, so that you can apply the fluorescent agent and being able to see where it's binding to the target tissue for removing cancerous lesion, for example, with safe margin, and also real-time tissue oxygenation, so that surgeons will know where those sensitive areas are, such as the blood vessels, that they should probably leave it alone during the procedures. And then also ultimately leading to what we are calling the next phase of surgery, which is augmented dexterity, which I will get to a little later in the talk. So with all of this data coming through about what's going on during a procedure, what we aim to do is to deliver insights and recommendation in real time at point of care, right? And we aim to achieve this by converging high-performing robotic system with AI intelligent algorithms, right? So that we can start to imagine understanding more of what's really important during a procedure that correlates to positive patient outcome. And when you have the foundation of good data, you can start to identify meaningful insights, which describes what really matters during a procedure. And they could have a direct impact on the desired outcome of that procedure. And for example, in the middle of the slide, you can see we have started to provide force feedback on our instruments with the DB5 release, so that surgeons can feel how much force they're applying when they're manipulating tissue during any procedure. And studies are already showing to the fact that when surgeons can feel and understand the amount of force they're applying, they tend to start to apply less force going forward, which is a positive an impact on the outcome of the surgery, right? And the patient outcome will be positive. So once you can identify some of these meaningful insights, we can start to question some of the things that could have even more impact, such as what type of surgical techniques are likely to create the best outcome, and what type of patients will likely benefit with some of those different techniques, right? And it's not just about the surgeons, so what will it take to help the care team in the OR to become better, more efficient, faster, right? So with that, we can begin to think about and identifying what makes good surgery, right? Again, with the aim of providing or hopefully having a positive impact on the outcome of the surgery. So, for example, you can take all those meaningful data that may be hospital-specific or pre-op condition of the patient, and the surgeon experience itself, the number of cases the surgeon has done, and their performance indicators that we also provide on how they manipulate instruments and so forth during different phases of the procedure. We can apply all of that to obtain objective insights that hopefully correlates to the desired outcome that we are trying to achieve, right? And then from all of that learnings, the care team, the surgeon and the OR staff themselves can apply back in a virtuous loop in future procedures. So we can have this continuous improvement from the learnings that we can have. Also, we can start to add context to understanding what a good surgery looks like. Right? So these are some of the examples of basically, or the different types of understanding that surgeons can have to better know what you're doing. So you have an example here on the left, our case insight, where it's post-operative case video analytics and segmentation to identify different phases of the surgery, and even within the phase, different tasks. Which instrument the surgeon used, how they use that instrument, if it was a force instrument, how much force they apply, if it's an energy instrument, when they apply the energy instrument and how. They can see all of that post-surgery to have a better understanding of their surgical procedure performance. And we can also help the surgeons to know what they're looking at. So in the middle, you see the Intuitive 3D model where we take the preoperative CT scan and we can convert that to a model where the surgeon can rotate to get better visibility into the tissue of target, usually some sort of lesion that you want to surgically remove. And lastly, then combined with all of that, know what is good. So the chart is a little hard to see here, but basically it shows so the change in amount of force and how often or for how long the surgeon was applying a force that beyond some threshold, and correlating to that to number of days the patient had to stay in the hospital. So with analytics like that, the surgeon can begin to know better what a good surgery looks like, right? And there are a lot of growing evidence about how surgical data science is impacting patient outcome. So these are some of the examples how if you are making more efficient use of the instruments or having the ideal stapler angle or applying some OPIs to the procedure, you can begin to reduce some of the side effects or post-operative complications and also improve the quality of the patients after the surgery. So starting again with the foundation of good quality data, identifying those meaningful insights, the surgeons can start to make better decision-making because at the end of the day, all of this additional information and analytics are trying to provide insights to the surgeons so that they themselves can make a better clinical decisions, right? So, for example, I share with you the example about the force feedback, and if there are other tasks in a procedure that surgeons have identified that may be affecting the desired outcome, we provide a safe environment such as our Now simulator where they can practice without harming actual patients, all of those tasks so that they can improve their better decision making based on all of the meaningful insights that we can provide. So this is sort of the bird's eye view of the concepts that I've been talking about. Making and building on the foundation of good data, identifying those meaningful insights that impact positively to the patient outcome, so that surgeons can make a better decision-making, clinical decision-making. But then we look through the next phase of surgery, which we call augmented dexterity. So our previous CEO, who is now the chairman, published a paper with Professor Goldberg at UC Berkeley and coined the term augmented dexterity. And in the paper, augmented dexterity is described as allowing robotic system to perform certain procedural tasks under the constant supervision of human surgeon. And what that enables is potentially elevating the skills of good surgeons to the level of the best surgeons. And the point is, we want to reduce the variability in how the clinical care is provided to the patients so that ultimately the outcome of the surgery and what the patients, their patient outcome, the variability in that is also reduced, right? And it goes with our desire to expand access to highest quality of care possible to everyone. And we're not doing it just by ourselves. And we have invested in our Da Vinci research kit, which you've heard previously. So he kind of stole my thunder a little bit. But so Intuitive has been investing in DVRK, Da Vinci Research Kit. And we are working with a lot of the academics on advancing a lot of interesting research, including augmented dexterity. So with that, with AI, we have worked with Johns Hopkins University, and they have used our DVRK to perform those tasks using, allowing the robot to learn how to perform those surgical tasks, which includes picking up tissue, picking up dropped needles, which is interesting. Apparently, the robot was never learned to pick up a dropped needle, but the model is so good that when it dropped the needle, it knew how to pick it back up and continue the suture. So there's a lot of exciting research going on, and Intuitive is definitely supporting all of that with things like the DVRK that we're providing. Again, all of this brings us back to, you're gonna get pretty sick of me saying this over and over, but it really goes back to the quintuple aim, and I think we all share that. Everybody involved in healthcare, the global regulatory bodies, the healthcare system, Intuitive, patients, surgeons, because at the end of the day, again, all of this is, we want to all try to achieve positive clinical outcome so that patients and the care team have better experience, lower the cost of care, and expand the access to healthcare at the best quality possible. So we have an emerging opportunity, right, to share quality data and enable this data science and AI, what we call surgical data science, so we can establish this virtuous loop of improvement that will lead to positive patient outcome. And these are some of the things you can expect from Intuitive going forward. So first is, connected to what I said about the force feedback, we can now start to measure impact of gentler surgery, right? Because once the surgeons start to actually feel how much force they're applying, they understand and they begin to apply less force going forward. So they can start to perform gentler surgery. And we can enhance the senses of the surgeons using those advanced imaging techniques that I described, such as the real-time oxygenation detection and fluorescence imaging and others that we're working on. And obviously working on AI and data to help identify tissues and sort of the no-fly zone to help the surgeons to stay away from sensitive tissues. And also, I think it's also important to maximize telecollaboration and telementoring, because we want to be able to have the best quality or experienced surgeons to be able to mentor other surgeons so we can bring up those other surgeons to a level of the same expert surgeons. Because that'll mean that more and more patients will benefit from the few that are the best surgeons. Using telementoring, we will be able to expand access to quality care much better. So again, but we can't do this alone, and we know that we need to work together with the global regulatory authorities and everyone involved with the healthcare system. And it's reality that we all need to work together. If this was US, I would say let's get together and sing Kumbaya, but I don't think you know what that means. But okay, so shifting gear a little bit. So what does it look like, right? Global AI regulation. So I just want to give you a little flavor. Some of you may know way more than I do, but when I looked at this, it's kind of fragmented. There's no consistency in a lot of the areas, starting with even the definition of AI. We don't have one definition of AI that all of the jurisdiction is applying. And the legal format is not consistent either. Some are acts that are enacted law that is binding. Some, like US, you have some executive orders, and other countries have some recommendation or self-guiding AI ethics program. So we have a lot of different ways that different jurisdictions are trying to not always regulate, but monitor and maybe guide towards use of AI. And these are some of the examples. EU AI Act is probably the most well-known because it's already enacted, it's already in force. And the EU AI Act is a horizontal rule that applies to everything. It's not sector specific, and it's risk-based, and it's risk to the fundamental rights of human being, which I think is great, right? But it does have this extraterritorial reach, meaning all activities related to AI, training, testing, even if done outside of the EU, if those output of those activities end up in the EU, it falls under the EU AI Act. And then there's other countries like China, Canada, and the African Union. They're working towards either enacted or pending centralized or some federated act to cover all of the continent, all of the country. So that's some of the similarities within this group. But then there are these other countries that are more pro-innovation and more maybe some deregulation and some sector-specific. I'll start with the US. US does not have a federal AI law yet. It's relying on each state to have its own AI regulation, which some have enacted, some have not yet. And so far, the federal government seems to be more leaning pro-innovation and more deregulation in everything, not just AI. So we shall see what happens with the federal government. UK is relying on sector-specific regulation with using the existing laws on those sections to apply the additional effects of AI in those sectors. And UK seems to be more focused on national security and sometimes relying on bilateral partnership across borders to apply some of the AI regulation. Now, Australia is really interesting, I think, because they are relying so far on voluntary AI ethics principles with no enacted laws. Japan, I believe, had just recently enacted a law, but it doesn't really have a lot of requirements, but really talks more about national goals on AI. So I did a little bit of homework on Brazil, so I don't know if this is a good idea or not talking about Brazil to Brazil experts, but please excuse me on this. So I know that the proposed Brazilian AI regulation has passed the federal state, but it's not enacted yet, so we'll be waiting for what it actually looks like final. It is more broad, territorial in scope, and it's similar to the EU AI Act, where it's not sectorial, it applies across everything, right? And I think it makes sense that Brazil's proposed AI regulation seems to be more close to the EU than others. And it also has risk categories. I do appreciate that it only has 2 risks, which the EU AI Act has like 4. Actually 5 if you include the prohibited AI Act activities. But I do think that there are potentially other already existing Brazilian laws that may affect implementation or use of AI. Obviously, that includes the ANVISA government, device regulation, medical device regulation. But there are others like, general data protection law, consumer protection law, and copyright law. Copyright law is very important when you talk about AI because AI needs to be trained on data, and the issue of copyright do you have the authority or the rights or permission to use the data to train your AI is always an issue. And also, that there are models out there that have trained on data escaped from internet and other publicly available data, but that doesn't mean those models have permission to train the model. So there's potentially a lot of issues related to copyright law. So I just want to sort of raise that. With that, as an attorney and helping with complying with all of the regulation, including AI, I'm waiting on the finalization of the Brazilian regulation so I can start working. Hopefully, it's very similar to the EU AI because we're already working on that internally, but we shall see. Okay, and I believe the last thing. Oh yeah, we want to transform healthcare, but we want to do it together in a partnership with everyone involved. Thank you. That's it.
Obrigado pela ótima apresentação.
Excellent presentation. In a certain way, you did the hard job here because it's hard to make question in such a complete presentation. But I selected some for you. First, I would like to know about your view since you told us about AI systems working, integrating different steps, filtering information, highlighting what is important. They do summaries, they highlight information, and they also disseminate good practices, making them a standard, and so on. I would like to know from you, since you are you know so much about this area, about the next steps. But I don't want to know about in long term, because in long term, we can imagine that future generations will think it's weird putting a doctor inside a surgery room. How do you do that? You need to clean the whole guy so he is not contaminating the patient. We imagine in the future, not so far away, we will be doing this kind of question. But the place of the patient is alone with the robot. Everybody will be outside. Nothing wrong will happen inside the room. But in the near future, 2, 3, 4 years, which are the advances in the use of AI with disruptive technologies we've seen in this field that you imagine will be applied in this kind of integration and in this type of operation in health?
Thank you for that question. I agree with you. We can talk about potential science fiction of the future. You know, I'm a Star Trek, Star Wars person, so absolutely, you know. I thought that would come like a lot earlier than I'm over 50, and I thought like, shouldn't we already have that already? Because I grew up watching those shows. In the near term, I think what's going to happen from practical implementation, because we are in a highly regulated industry, and we do have to get it regulated. And also, you can't just jump from now to suddenly everything is autonomous and you know, hands off. So what we learned so far at Intuitive is that with the release of our DB5, surgeons really appreciate having more of autonomy. And so I'm going to use autonomy in a surgeon autonomy sense. Meaning the surgeons have more abilities, information at their fingertips, so they're able to do more. With robotic surgery, as you know, the surgeons at the console removed from the bedside table, and you have the bedside assist that assist with changing the instrument and so forth. And sometime in the past, things like an insufflation, the surgeon had no control over that. But now we're providing more of the control back to the surgeons. So I think near term, what's going to happen is that because the surgeon still needs to retain the clinical decision making, the surgeon, everything that AI is going to accelerate is providing more and more insights and the ability to have the surgeon have autonomy, do more, right? And on top of that, reducing the, again, variability of how each individual cases are performed from one surgeon to another. So I think that means to some level of what we are calling augmented dexterity. We don't call it autonomous surgery because we believe that yes, you can have the robot perform certain tasks, but it should still be under the supervision and clinical decision-making made by the surgeon. So I believe in the short term, you will have this combination where certain tasks, maybe some suturing or some low-level tasks that will be performed by the robot, but the surgeon will still need to be there to make decision-making, and that's in the intraoperative stance. But I also think that post-operative, there's a lot of data still out there trying to make sense of what really looks good, like what does good surgery look like? And I sort of like to think of it as like having a digital fingerprint, since we have all this digital data on what we can map to, yes, that digital fingerprint looks like a good surgery. Then hopefully we can replicate that to provide training so other, maybe less skilled surgeon will be able to elevate their level of surgery to the level of experts. Yeah.
Obrigado.
Thank you for the answer. Well, since you also mentioned the regulatory approaches from different countries in your presentation, I would like to do a little bit of research with you, if I may. In your opinion, considering your experience with the different regulatory approaches, which would be the most appropriate one to foster innovation and at the same time not compromise safety and performance on the products and services offered to the population? The appropriate choice for your company. So what is the type of regulatory approach that in your opinion and in the company's opinion, you think it's ideal, you feel more comfortable to work with, and it's more pro-innovation so you can offer them with safety?
Yes. So, in my opinion, so this will be opinion of Holly, not intuitive. In my opinion, as an attorney, we already have a regulatory body that's working with industry to help clear products to be safe, right? We have those laws already. Now we have this AI going on. So I wonder if we need a whole new set of laws that governs every type of AI and then toss it on top of everything else. So I wonder if we can maybe have a model where we continue to have better discussions with the regulator, the industry, at the beginning of the design process. So both sides have the right expectations, right? Starting with what are we talking about when we say AI? What do we mean by machine learning? And when we say good quality data to train those, can we maybe potentially have better, same understanding, standard, maybe a standard to say that this is what we consider good data. What does it mean? And discuss why that's necessary, right? So we can have those discussions. But in my opinion, we already have wonderful folks closest to the problem, because I'm always about let the folks closest to the problem solve it. So it should be the medical device regulators that knows more about the medical devices, the reasons why you have those regulations, right? I don't think those reasons change just because you have AI. It's just that for now, it's the shiniest thing out there, and potentially it could be harmful, sure. But what does that mean? And can we just align it to our central objective of clearing safe product for the patients? So I don't think there's one existing already out there. I think the EU AI Act, I think their heart is in the right place because they are focusing on fundamental rights of people, and which is great. Who's going to argue with that, right? But I wonder if it's just a huge sledgehammer to apply to just everywhere. Whereas I feel like if we can have more intimate discussions with the part of the MDR process, where you're applying AI as another tool, because I look at it as just another tool, just another tool. But at the end, it's an extraordinary tool, but it's just another tool to elevate the potential features and potentially positively affecting lives of patients. But shouldn't we just still follow the central focus and the North Star of why we have medical device regulatory body, right? We should just align with that, and that's how I feel. As myself again, I'm not speaking, I don't have intuitive on that question. Thank you.
Adorei sua resposta.
I loved your answer, and I was really happy to hear that somehow, at least here in ANVISA, we have a similar opinion to the one you just described. I think it's a step-by-step process with good communication and without scaring or without being scared with this new technology. Because again, it's like you said, it's just another tool. And I have one more question before I open for the audience. It will be a quick one. And the question is about the accountability. issue. You are an attorney, so I imagine you have an opinion on that. And I would like to hear your brief opinion on the accountability issue.
Okay, so on the accountability, as an attorney, again, this is my opinion, my personal opinion. I think we should think of it as another example of existing laws on manufacturing defect, right? So if something goes wrong, if the cause of it, so we should look at the root cause of when AI goes wrong, right? If the root cause is manufacturing defect, where there were some issues in the manufacturing the AI system, then I believe it should be the fault of the manufacturer, right? But if it's not a part of a manufacturing defect, then we'll have to see, then should it apply to the surgeon? Well, I think it depends, right? Did the surgeon apply the level of care that he should have, whether the AI was there or not? I don't think we're at a place where the healthcare provider, surgeon's duty of care just goes away because you have this wonderful autonomous system, right? Because we're all thinking human beings with our own professional responsibilities. I have my professional responsibility as an attorney not to act like a non-attorney, and some brainless dumbass, right? So I can't do that. So I think everybody, including surgeons, should use this tool in a responsible manner, right? So I think we should look at all this from case by case. And so I do believe it's a fact-driven, but there probably should be an addition to the existing, manufacturing defect-related laws in each country, based on what each country its beliefs are, so that you can safely try to protect the consumers, because consumers don't know anything, right? They're trusted in the fact that, yes, this is an approved device, and how was it approved, right? Who approved this, under what circumstances and requirement? So I do think that you probably need to update on existing laws of the nation on manufacturing defect and liabilities related with that. But those liabilities should be based on the actions of the individuals, right? If you're acting without a malice, or you're acting, outside of the scope of how you should be performing within your responsibility as your role within the health system, then I think potentially everybody might have some culpability, right?
Sim, uma resposta semelhante, ó.
A similar answer to my previous question. It's a tool, and we already have existing laws for accountability, and they should be applied to that as well. All right, do we have any questions from the audience? Thank you so much for coming to Brazil for the presentation. Thank you, Intuitive, for bringing this, your speaker. I was very happy to see your knowledge on our bill of law here in Brazil. We are all paying a lot of attention in that. And I have a question. In your opinion, do you believe we should have a more specific law focused on healthcare products regarding AI, or should we continue on this general approach? So a general approach for AI. And in which cases it would be beneficial to have a more specific legislation for a sector? And why would it be better to have a general legislation that doesn't talk specifically about healthcare products?
Yeah, thanks for the question. My personal preference is to have more specific law for medical devices, because I believe we're in a unique industry because what we do affect people's lives, right? And I don't believe general AI law should apply to everything. Now, you could think about having a general principle for how to regulate AI at the national level, but then have more specific laws that gives more authority to, like ANVISA, for example, right? To apply the law, again, within the existing authorities that ANVISA has, and the purpose for which they're already regulating medical devices. And I think if you have those specific laws, you won't have to have this potentially ambiguous situation where this more general law, now, not only does it apply, but how do you implement that at the sector level, specifically something like medical devices? I kind of worry about that because as an attorney, we don't like ambiguity. We would love to have more certainty so we know what our risk levels are and we're complying and the reasons why those requirements are there. So that's my personal opinion.
Any other questions? Well, since we don't have any more questions, I think we can move to the next session. Thank you so much, Mr. Lee, for your presentation. And of course, our official picture. In the meantime, I just wanted to highlight that we have more than 300 people watching us online, besides all of you who are with us in the auditorium. And I also would like to announce that we are going to have a 15-minute break. Many of us have appointments, flights to catch, so please be mindful of the time. So I will see you back in the room in 15 minutes.
Recording stopped.
Muito bem, são 4.
All right, now it's 13 past 4 São Paulo time. So we will return with our activities. We are back here in the auditorium and online for everyone watching us for our 6th and last panel of the day. The use of real-world evidence in project development. And to moderate the discussion, I would like to call Dr. Karen Knopfs, General Manager at GGTPS at ANVISA, Brazil. Dr. Karen will be discussing the topic with Dan Stevens, PhD and Global Advocacy Fellow from Boston Scientific in the United States. Welcome.
Good afternoon. Thank you very much for being here. Thank you for your time. My name is Dan Stevens. I work with Boston Scientific, and I'm a Global Regulatory Fellow. I'll be talking to you today about real-world evidence and the development of real-world data to real-world evidence and how we've used it at Boston Scientific to inform some of our product development and some of our project development. So today we're going to be talking about, we're going to start with the context of today's talk, meaning I'm going to start with a little bit of background. I'm going to talk about the regulatory framework and global trends, and I'm going to talk about some use cases with real-world evidence as it applies to product and project development. Then I'm going to talk about 2 specific case studies that leverage real-world evidence for regulatory approvals, and then some key considerations for regulatory acceptance and challenges in future directions. So before I get started, I have to go through a couple of disclaimers. First of all, today's topic and what I talk about is my opinion. my experience and doesn't necessarily represent the position of Boston Scientific. I'm also going to talk about some specific examples of healthcare treatment. This is not medical advice. If you need medical advice, please seek out a physician. And then lastly, the products that I'm going to be talking about and what I'm going to be talking about is intended for educational purposes only. I am an employee of Boston Scientific as well as a shareholder, and so I have a little bit of bias in that direction. So the regulatory environment and real-world evidence. Real-world data and real-world evidence real-world data are derived from routine clinical practice. When I think about real-world data, I think about it very, very broadly, and I'm going to encourage you to do so as well. And in just a few slides, I'll explain what that means and when I talk about real-world data very broadly. Real-world evidence is the result of analysis of real-world data. So it takes some methodology to convert real-world data to real-world evidence. I will be speaking mostly about real-world evidence today. I'm not going to talk a lot about methodology. We could spend a day talking about that. But I will be touching upon the importance of methodology when we consider real-world evidence as being fit for regulatory purpose. And then lastly, when we talk about real-world evidence, when I talk about it, I'm talking about it as a source of evidence used to inform decision-making and add to and contribute to and complement a total evidence package. So a few definitions that we need to go over and make sure that we are in agreement on. There's some very basic terms that we're going to talk about. And part of that, I'm going to be talking about randomized controlled trials. And I will sometimes abbreviate that to RCT. And I might say it really fast. And when I talk about RCTs and randomized controlled trials, in some cases, it kind of applies to clinical trials more broadly. But this is not the same as real-world evidence, and we'll get to that in just a minute. I'm going to talk about retrospective and prospective studies. And a retrospective study is a circumstance in which you're looking backwards in time to collect data that's already been recorded. In a prospective study, you're establishing a plan and a strategy to collect data moving forward. You can collect real-world evidence prospectively. It's typically collected retrospectively. But I'm going to be talking about retrospective examples and prospective strategies. And this is how I use these definitions in these words. I'm going to be talking about having a pre-specified analysis plan. This is tremendously important in real-world evidence. I'm going to be talking about generalizability. Generalizability is the ability to take the ideas, the concepts, the conclusions that you're drawing, and having them be representative or applicable to a population. The goal of research and the collection of clinical trials is to develop products that have a generalizable positive impact on patients, meaning it helps everybody. And then I'm going to touch on missingness very, very briefly. Missingness is a topic in analysis of real-world evidence that gets a lot of attention and a lot of negative attention that might be inappropriate. And I say that because we think about missingness in the definition of as applied to randomized controlled trials. So in a randomized controlled trial, we have patients that are coming in on a very specific schedule. And we're doing comparisons between a control group and a treatment group on a very specific schedule at very specific points in time. And if a patient doesn't show up for a follow-up, it creates a gap in these comparisons. The data are missing. And in a randomized controlled trial, that's a real problem. So if you have 100 patients total, and 2 of them don't show up in one group, that's a significant percentage of your data for a data point just getting started. In real-world evidence, it's a little bit different. And missingness may not be as big a deal as we think it is, because in some cases, patients are being seen at different frequencies. I'm not going to go into a lot of detail except to say data availability data availability is a big deal when we talk about methodology in real-world evidence. But I do want you to think about missingness. When you see it in the future, try to think about missingness a little bit different. Now, fit for purpose is a topic that I'm going to discuss with each of the use cases that I present. And when I talk about fit for purpose, I'm going to be talking about 4 different basic measurements of the context. One is a regulatory context. How are these data being collected to be applied in a regulatory context? The clinical context, where are the data coming from? Is this part of routine practice? Is it well accepted? Broadly, how are the data being drawn from clinical practice? Data availability, we're going to talk about is reliability and relevance. And the reliability and relevance are both quality measures. And then lastly, the methodology. I'm going to be very brief with the methodology. Again, that's a very deep and very detailed statistical concept, but it basically is the process by which you convert real-world data to real-world evidence. And your methodology has to be pre-specified. Otherwise, that brings questions to the quality. So this is a diagram taken from a paper that was written by the Duke Margolis Institute for Health Policy. And it's from a publication they had called Characterizing Real-World Data and Relevancy for Quality, Characterizing Real-World Data Quality and Relevance for Regulatory Purposes. This gives a more detailed overview of these characteristics of fit for purpose, being the regulatory context, the clinical context, and then what they refer to as data considerations, I refer to as availability with relevance and reliability. And then lastly, methodological considerations. This white paper has served as a foundation for a lot of the guidance documents that we read around the world that are published by different regulatory agencies. And if you're not following the Duke Margolis Institute for Health Policy, I encourage you to do so. They've generated a variety of papers, white papers, and peer-reviewed publications about clinical evidence and clinical evidence strategy, and several of them are specific to real-world data. So the evidence pyramid that we've all seen, we've all kind of grown up clinically with experimental science, understanding that some methods of data collection are more robust and more rigorous than others. At the very bottom of the pyramid, we have animal studies and in vitro studies, which we refer to as, in the medical device industry, as sort of preliminary data. So the early data that we collect to support the entry of project development. And then we move into, as we start moving up the data pyramid, we move into case reports, case-controlled studies, and cohort studies. These are generically referred to as observational studies. And for quite a while, within the practice of healthcare, observational studies served as the foundation for developing ideas of moving into clinical trials and testing new hypotheses. The challenge that we have now is that the data that's being collected is so voluminous, it's such a massive amount of data, that observational studies are very difficult to execute anymore with the volume of data that we're collecting. We're going to get into that in just a minute. And then as we moved up, randomized controlled trials are sort of the gold standard in collecting clinical data and testing new products. So despite being the gold standard, randomized controlled trials have some problems. And there are some challenges that are inherent with any form of data collection. But in this case, randomized controlled trials typically take a really long time to complete and to collect the data. They're highly selective for patient populations. They're highly selective for sites of practice. They're highly selective for the methodology of practice. As a member of the medical device industry, I've been working in medical devices for 26 years, and we are very careful where we go to take clinical trials. We do not randomly pick sites. So when you think about randomized controlled trials and the data that we do the process that we go to collect data in those settings, those sites that are selected are not representative of the delivery of healthcare to the general population. Even though some of the findings that we draw from randomized controlled trials may be statistically positive, They may very well lack clinical relevance. With populations that we study, they're often too small to truly be generalizable. They're very informative. And please do not misunderstand. There is absolutely a place for randomized controlled trials in product development. We do them as a company. Boston Scientific does randomized controlled trials in all of our business units. We enrolled 23,000 patients in different clinical trials last year. It is a big part of our clinical strategy, but it's just a part of our clinical strategy. And lastly, randomized controlled trials are expensive, but real-world evidence trials can be expensive also. So when we get back to the data pyramid, where does real-world evidence fit in? And it's kind of in the middle, but it overlaps observational studies as well as randomized controlled studies. And I say that because in some circumstances, we could draw data, we could draw populations from a control population into a randomized or into a real-world data set. So real-world evidence is not a new concept. We've been observing and collecting real-world evidence for decades and collecting it informally for centuries. We just don't think about it in that context because we tend to think about real-world evidence as strictly coming from electronic health records. Large databases provide sources for analysis, and these large databases are available all over the world. And I'm going to get to discussion of kind of the global regulatory horizon or ecosystem in just a moment. But there is a criticism on real-world evidence, and that criticism is that it itself is also biased, and it can be. But there are tools that we have to employ to reduce bias in real-world data sets and to also deal with how generalizable these data can be. Now, real-world evidence also is often criticized for only being retrospective, but that's not necessarily a negative. It can be if not controlled correctly and tested correctly, or if the methodology doesn't consider the biases that I'm mentioning. But what if the size of the data set is so large that it allows us to draw a much stronger inference that's generalizable to the total population? And so what does this data set have to be? Does it have to be 1,000 patients, 100,000 patients? What about 100 million patients? Luciana Machado just showed us a paper of a data set that was pulled for surgery with 218,000 patients. I think we could probably all agree that a sample size of 218,000 patients might very well be representative and generalizable to the population that it was sampled from. That's a pretty big test sample. Earlier, I said that there's absolutely a place for randomized controlled trials in a clinical evidence strategy. And the way that we think about evidence and evidence strategy is to think about evidence as a total package. We refer to it as a compendium. So there's a variety of components that contribute to our evidence package. So the prior evidence package is what I mentioned earlier as being on the bottom of the evidence pyramid. And this is toxicology, biocompatibility, animal studies, in vitro studies, desktop studies, the things that we're going to do that support the basic safety and reliability of the product we're testing. But when we start to move into a strategy to collect clinical data to demonstrate the safety and the efficacy of a product, we start looking at how can we bring evidence together from every imaginable source. Where can we find evidence that supports the safety and efficacy of these products? So sometimes it can only be done with a clinical trial. And so there are circumstances in which that's really the only way to test the device. It's a brand new product, or it tests something that is so specific that we need a highly controlled environment to eliminate any concerns or confounding factors. Sometimes the question can be answered just by collecting real-world evidence. And I'm going to show you an example of that in one of our use cases. But often, As we think about clinical evidence and bring clinical evidence packages together, it's a combination of clinical trials, real-world evidence, and then other sources of evidence that we bring together as part of the prior evidence package. So when these 5 blocks, the regulatory context, clinical context, relevance, reliability, and methodology to generate real-world evidence, are how I'm going to refer to some of the use cases that I'm going to discuss, and I'm going to be talking about the aspects of each of these use cases and how it completed these concerns or considerations for fitness of purpose. So both of the examples I'm going to talk about are for indication expansion. I meant to lead with this in the disclosure, so I apologize. And Mr. Lee, no offense as an attorney. When I was putting my talk together, I was advised by legal counsel that I can only talk about our use cases that are in the public space, which is reasonable. We have a lot of use cases, and this is an aspect of our real-world evidence is an aspect of our clinical evidence strategy that is becoming a bigger and bigger part of our evidence strategy overall. And so, unfortunately, I can't talk about anything except some label expansions, but it's being used in other ways as well. Our clinical context, I'll be discussing how the product is approved and we're being used in the marketplace. In some cases, I'll be talking about literature that's available that we drew from to support a regulatory submission. And a lot of people don't necessarily think about the literature as a source of real-world evidence, but there absolutely are the publications of observational studies that, when pooled and even on as standalones, can often be a valuable source of real-world evidence about a product's performance. I'm going to be talking about availability and generalizability of the data with respect to relevance. I'll talk a little bit about how the data are collected. I'm not going to talk a lot about data quality, except to mention how we validated the data that I'll be discussing in the use cases. And then again, the methodology was typically through chart reviews, historical performances, and I'll leave the statistical analysis part out of today's discussion. So a quick survey of the regulatory landscape. This is a heat map or a diagram that's maintained by the Duke Margolis Institute of Health Policy that's updated and shows the publications of guidance documents around the world by regulatory agencies in each country. There are a lot. Just since 2017, there have been over 50 guidance documents published worldwide. Now, this is both pharma and devices. Pharma tends to lead devices in this setting, meaning just is ahead of devices in applying real-world evidence and guidance, but not by much. And devices typically learn from pharma, and we continue to move forward. Boston Scientific has a couple of pharmaceutical products, so therefore we are a pharma company. I mean, we're not considered big pharma, and we're not, but this is something that we monitor as well. Next month, there's a meeting in Europe for the International Society of Patient Outcomes Research. And at that meeting, there's a debate that's scheduled to happen about whether or not we have enough guidance specific to real-world evidence around the globe. I would argue that we don't. Every guidance document that's published continues to add to our understanding and processes. And I want to thank ANVISA, Taiwan, FDA, the couple of the notified bodies, and really the EMA and the European Union and the US FDA are the only regulatory agencies that have come together and are in agreement on reliability, relevance, and some parts of methodology. Now, I appreciate that the guidance document from ANVISA is in the pharma space. That's okay. We appreciate the attention, and we thank you for the clarity and the transparency. The harmonization of coming together through organizations like IMDRF, as well as just working together, will make this entire ecosystem much easier to navigate for all of us. And this brings innovations to patients much faster. So this is a figure that I took from the internet, a company called IQVIA, and it represents just a document about the healthcare ecosystem. And I put this up to reinforce the volume and the sources of data that are available, and to once again encourage you to think broadly about real-world data. If in your mind, when I mention real-world data, you immediately think electronic healthcare record, yes, that's a valuable source. But there are a wide variety of other sources. And so in the light green, we have a patient and how the patient enters the healthcare ecosystem and all the places the patient may come into, the pharmacy, different electronic medical records, an imaging study, lab and a laboratory where they're having testing done. Then as they come in, they'll be treated by physicians and other healthcare providers, and they generate a whole body of data that's related to this patient's well-being and outcomes. The institutions where the patients are treated also create entire bodies of data. And then these also represents multiple sources and coming also from folks like us, from medical device companies that generate data through registries, through coming together with medical societies and generating registries to collect information longitudinally in the performance of the products. And so I hope that when you look at this, it makes you a little bit dizzy that you see so many blocks and so many small words they're written in small text, because this is what the healthcare ecosystem looks like. And the data, the digital healthcare data, is growing at over 30% a year. So there is a tremendous opportunity to collect information and to render that information from just healthcare data into evidence to support the delivery of better patient care and better patient outcomes. This is a map that was drawn from a publication published 2 years ago in the current landscape of global regulatory acceptance from real-world evidence. And at the time, this was a collaboration of industry, clinical trialists, and the FDA to do a landscape analysis of the available real-world data, real-world evidence guidance documents that were available specific to medical devices, and how they offered guidance and influence into various aspects of the medical device product development. And so I'm not going to go through all of it except to say real-world data comes from a variety of sources. Through methodologies, statistical methodologies and analysis, it's converted into real-world evidence. And that comes down to feed into supporting pre-market authorizations, post-market requirements, safety signals, as well as product development and research. From a business process, real-world evidence is also brought into economic analysis, reimbursement, and public health surveillance. Yesterday, one of the presenters, and I'm probably going to butcher her name, Dr. Fatini? Okay. Dr. Fatini had a comment that the data are there. We just have to pull the data out. And she was speaking specifically about the experience of the public health sector here in Brazil. And I would absolutely agree. That is a key observation. And that's key for us globally. The data are there. We just have to find it and pull it out. So to Boston Scientific, and how we think about product development, project development, and then we're going to get into a couple of very specific use cases. So in the medical device world, when you create a device or you're thinking about iterating a device, it starts with some kind of idea. And that idea is informed, developed, catalyzed through review of the literature, just plain invention, creativity, thinking about clinical testing, and all of these sources of information, these ideas that we use to guide our thinking, are refined through a very defined development process where we test for quality and we test for reliability. And then it comes into an actual testing environment. Now, this may be in a lab, on a bench, it could be in a clinical trial. But it goes from this ideation, this idea development, into develop and into testing. And then once we get into testing, and there are a variety of stages of testing, then we start really looking at relevance, reliability, and the methodology that's used to draw conclusions from this testing to determine what the truth is about this device's performance, its safety, and its effectiveness. Hopefully the device goes from testing straight to approval. Sometimes it doesn't. And when working with our regulator partners, they may come back with questions to say, there are a couple of questions here that we have. Okay, good. There's a button I'm not supposed to push. Did I push it? Sometimes our regulator partners come back to us and they say, hey, there's some questions you didn't quite finish. And we need to go back into this testing phase to complete our submission package for approval, and then we launch a product. At that point, we still collect data, and in some cases, we're collecting more data more rigorously than we were even in the testing phase, because we have to continue to monitor this product for safety. In the last 10 years, we've started following the monitoring, launching and monitoring phase even more closely, because we also need to become better informed about the long-term performance of our products. 40, 50 years ago, we might implant a heart valve in a patient, and the goal was to keep the patient alive for 5 years. We might put a pacemaker in a patient, and the goal was to keep the patient alive for 10 years. I have a friend who's had a pacemaker for 40 years. Now, it's not the same pacemaker, but we have to now think about this monitoring phase much differently than we did before. We need to be thinking about this monitoring phase on a much longer time horizon. And the most effective way to collect those data are through collecting them through routine care, real-world data. So, real-world data and real-world evidence can be used to support clinical trial design, can be used for label expansion, supplemental approvals, can be used for post-marketing surveillance, safety surveillance. It can be used for cohort characterization and contextualization of clinical trial results. When I was rehearsing this talk in Minnesota, one of my advisors said, you have to think about your audience, and that term is going to be very difficult to translate immediately. I challenged that with her, but she had a good point. And what she also helped me understand was that means a lot to me, but what this means and how we apply this at Boston Scientific is to consider a population that we're studying and to go out and collect a volume of data about a question we may have. So we recently had an example that I can't go into a whole lot of detail about, except to say we were very curious about how this product was performing in the marketplace and whether the performance in the marketplace mirrored what we expected from its initial clinical trial that was done 10 years ago. So we did a clinical trial 10 years ago. We did a randomized controlled trial. We had 250 patients in each arm. At the end of the trial, the device performed great. It was exactly as we expected. It improved the therapy that we were using it on to deliver health care to the patient. And we were curious about how it had been adopted and whether the same performance held true now that it's been in the marketplace for 10 years. And when we went out and looked, what we found was that it actually was performing better than what we had originally expected. We had set up a pre-specified analysis where we looked at and set very specific safety and efficacy targets. It dramatically exceeded both of those. And then when we looked a little bit closer, we found that it wasn't being used in very specific populations. And this observation was done in the United States. And when we looked at that, that really raised questions within our internal team to try to understand what have we missed? How can it be used in one group and it's available and not be used in another group? That's an example of cohort characterization. We were able to look at a real-world data set, analyze the data set, and come forth and realize that there are things that we need to do in the post-launch phase to raise awareness and education about the utilization of this product to other populations that can benefit from it for whatever reason or not. We can estimate intervention effects, And we can be at the population level of estimation. We've done real-world evidence analyses where we've started with several million patients in different countries. And when you're as focused as that with a large sample size, I'm pretty confident you can do a population estimation when you're sampling a significant fraction of the country's population. And then we also use it to innovate technology and algorithm optimization. And this is one of the examples that I'm going to be talking about today, was a label expansion of a product that was something we've been very interested in doing, but for technical reasons had some constraints. And I'll explain that as well. Okay, the two examples I'm going to discuss. One is a product called wall stent, which is a stent that's used in large veins to reopen the veins that become occluded. And another is a product that's used in pacemaking, in delivery of an electrical impulse to the heart, to make the heart beat more physiologically. Let's start with wall stent. So venous wall stent is a product that is introduced into the body. It is deployed into an area where a vein is occluded, and it's expanded to open the vessel that's closed effectively. This is an X-ray image, and this is a vein in the pelvis. I think it's the iliac or femoral? Femoral. No, iliac. It doesn't become the femoral until it gets a little further south. So it's deployed here, and this image in this vein, it's in the pelvis, but it's actually kind of in the leg. That image was published a couple of years after the product was approved, and that was used off-label. So the initial approval of venous wall stent was specific for the central venous system, only in the trunk, in the human trunk. And we noticed, or it was brought to our attention, that this product was used off-label and started to be used off-label immediately. As soon as we went into the market, physicians started using it to open up veins in the legs, lower legs, anywhere they could do it, because it was the only stent that they didn't think posed a danger to the wall of the vein. Veins have very thin walls. They're very, very delicate. And if you rupture a vein, and a big vein, it's a major problem. And so this product was adopted off-label very quickly. I wasn't at Boston Scientific at this time. I have talked to people that were, and they told me that it was a few years after the product was on the market that they started to notice publications and poster presentations and podium talks, and there was a lot of concern. And then we realized pretty quickly, and the physicians told us, no, we're doing this on our own. This is something that we're very interested in following up on. So the original approval, again, in the innominate and subclavian veins was in 2001. We started to look at building a real-world evidence package to try to expand the labels, and we started to realize this was going to be a little bit of a problem. At the time that we were collecting this data package, electronic health records had been implemented and were being adopted, but not like they are now. This was several years ago. Secondly, we had a lot of publications in the literature, but they were considered very unconventional at that time. We had a lot of poster presentations, again, very unconventional by regulatory authorities. We knew that we were going to be concerned, and having meetings with the FDA, they expressed a concern about whether or not we would have missing data elements that would indicate that we'd missed adverse events. When we look at the literature doesn't always report adverse events. They report an experience, but they don't always report adverse events. The data points that we were interested in collecting weren't standardized. So in an electronic health record, the data are all collected in similar fields. When you start looking at literature and combining journal articles, they don't report the data the same way. And literature reporting standards also varied, so depending upon the journal the articles are published in, you may or may not have the same information published in all of the articles that are being published. And so there were some challenges with putting this package together to support label expansion. And so what we did was we used the original study and we set up the original clinical trial that we used as sort of a foundational control, if you will, to establish some safety thresholds and an adverse event rate. We had a investigator-sponsored research, investigator-sponsored trial who had done a clinical study in 67 patients, and he agreed to allow us to do an intensive chart review. And then we had 37 manuscripts that were published that included 2,268 patients. So earlier I showed you an image where we use a variety of data sources to complete an evidence package. And this is a really, really good example of that. Any of these alone, any of these sources of evidence alone probably don't justify label expansion for this product. They don't answer all of the questions of being fit for purpose. This is one of the publications, Dr. Gagne, that was a publication about the investigator-initiated research where we did the chart review of wall stent placement. And he had pre- and post-treatment imagery that he collected as part of his standard of care. We had his notes, and we also had hospital records to validate the adverse event rate and the outcomes of these 67 patients. And then this is a listing of the 37 articles that were used to bring the data together to support this evidence package. When you look at sort of the fitness of purpose of these, this indicated the regulatory context was an indication expansion. The clinical context was that this product was approved and it was being used extensively. There was significant literature available. The data were available once we were able to come to an agreement to go to do the intensive chart review, and the data were generalizable. The data collection and data quality were validated by the initial clinical trial and then by the chart review and the hospital record validation of the investigator's site research and the historical performance in the literature, and all of this was coupled in for the methodology to demonstrate the safety and effectiveness of this product. And it won label expansion. So the next example is a cardiac pacing example. And I'm gonna ask your patience while I walk you through some of the background for this. I wanna start with the middle image. This is an X-ray image of a human, of a person. This is the spine that runs down the middle. This shadow in white, and for those of you that online, hopefully you can see the laser pointer. This is the heart. This shadow is the heart. This product, this device here is actually a pacemaker. These white lines that come down in this curve are the wires that conduct electricity from the pacemaker into the heart. And this lower wire that runs parallel to the bottom of this image is the wire that conducts electricity into the ventricle. This is really what makes the heart beat. Now, both wires are active, but this is the wire that makes the heart beat for the example that I'm going to discuss today. Now, if we look at the left side, left panel, this is an EKG tracing. This upper tracing, the circled on lead 2 with the top tracing, is a normal EKG. So this big spike is the electrical signal of the bottom of the heart beating. It's called the QRS complex. And this is what you kind of expect to see. You see a patient with a normal heart rate, normal heart rhythm, normal heart. That's kind of what you expect to see. Narrow, upward, fantastic. This lower right tracing is the EKG signal from a heart that's being paced. And you see it's a little bit wider and it points downward. And this is being taken in the same perspective, meaning that in a normal heartbeat, we get this upward deflection of the of the EKG with the QRS complex, and in a paced heartbeat, we get this downward deflection. And the reason is, in a normal heartbeat, so back to the middle panel now, in a normal heartbeat, the electrical signal starts at the top of the heart and it propagates down through the heart. And that method, that activation process causes this upward deflection. Now that is Super simple, and to any cardiologists and electrophysiologists that are watching, I apologize for being so simplistic. This bottom tracing, where the signal goes down, is because the activation is starting at the bottom of the heart and it's traveling upward. And this intuitively, you may think, oh, that's bad. Like this and that are really, really different. But the reality is having a pace beat like that is a whole lot better than not having a heartbeat at all. And so when you think about the trade-offs with medical devices, our goal is to develop devices that help patients, that bring back a quality of life, restore health, to make them better, live longer. And a pacemaker does exactly that. There are circumstances in which a paced beat causes some problems. And chronically paced beats can cause problems. Now, that being said, there are millions of people who have paced beats, their heart is paced 100% of the time, and they're doing great. So please don't understand. I'm not saying that paced heartbeats are bad, but I am saying that a paced heartbeat coming from the bottom part of the heart is not physiologic. It doesn't look like a normal heartbeat. And when we develop a medical device, what we really would like to do, we would like to develop a medical device that is a perfect substitute for what happens in normal physiology. Can we make a physiological test look like it's natural with whatever this intervention might be? So that was one of the questions that we asked, is how can we make a pacemaker deliver activation patterns to the heart that make it physiologic? How do we approach this procedure to have a normal response, normal in quotes, response to pacing? And how do we know if this type of pacing is actually reliable? So we've known for 25 years that you can do this. We've had testing from the late 1990s that showed if you put the lead in the pacemaker lead, the wire that conducts electricity, if you put it in a specific place in the heart, it will absolutely generate a physiologic signal on the EKG. It looks like a normal heartbeat. It looks like your heart is being activated just like naturally. The challenge is putting the lead in that position technically. The physician to manipulate the lead, to put it in the place it needs to be, is very difficult because the space, the place that it has to be, is about the size, the surface area of my pinky, and it's in a heart that's beating, it's moving, and cardiologists and electrophysiologists are trying to place a wire that's very thin in a liquid environment that's moving into a target that's very small. And yet they do it. But it's very, very difficult. And there was a publication in 2018 that followed patients that were paced in a physiologic placement or in kind of the traditional placement, and they found that their event-free survival rate was higher. They did better, they lived longer if we put the lead in this specific place. Now, one of our competitors developed a lead and a set of tools to implant the lead in that exact place. And they studied it and they launched this, and it's great. It's a great product. It's effective, it works well. And we were approached by a physician at a meeting who said, I can't believe you guys aren't doing this. And we said, well, we'd like to do this, but it's really difficult, and we're looking at this. And he said, I've been doing this with your product for 2 years. And let me tell you, it works great, and it works better than the other guys, and this is why. And he had been working with his own process and a couple of his friends, and they had been taking measurements during the implant of these products that we wouldn't have necessarily thought of in the design of a clinical trial. But these are electrophysiologists. This is what they do. And they knew if they took very specific measurements in the heart with the placement of this lead, they would know exactly where it was. And so this physician initiated a study that included 8 centers and 1,122 patients that they had kept very detailed records in as part of their normal implant process on the placement of one of our leads in this very kind of atypical place. And they were using a tool that was developed by another company that we weren't aware of. And this other company had developed this tool because they knew this was a market, and they started launching it, and it was adopted, and we have this available data set now that came to us from the sky. So in studying this and doing this chart review with this real-world evidence, one of our concerns was whether this was unique to this set of data, these 8 sites that have collected this 1,100 patients. And so to validate those data, we have a remote monitoring system called Latitude, where we collect information from patients, or I say we collect information. Patients use that as a platform for remote monitoring. So their data are uploaded into a cloud-based system that their physicians have access to. We get consent to access the data, and we can go in and basically data mine that data set, and we found 860 patients who in their implant notes had included placement of the lead in this same place. And these 800 patients were not part of this 8-site data set. So they served as, effectively, an external control group, validated the performance of the lead and the performance of the measurements, electrical measurements over time. And this served as our quality validation. And so it met the safety and effectiveness endpoints. The study met the safety and effectiveness endpoints that we'd originally pre-specified before we ever started the analysis of the data. We were granted label extension to the existing leads. And as a kind of a sidecar, as an accessory, if you will, their label expansion was also granted the implant delivery tool for this other company that we were working with, which is sort of a serendipitous finding. I'm not aware of any submissions where 2 products, it wasn't approved in the same expansion, the same submission, but I'm not aware of any 2 companies that kind of came together for that. So the regulatory context was a label expansion. The clinical context was that this idea, this clinical approach, was broadly accepted as being beneficial to the patients. It was being practiced by physicians who wanted their patients to have better outcomes, but didn't have the tools to do so with the products that they preferred. We did a data review that was required to validate for adverse events, and we did this data review on those 1,122 patients. So again, another intensive chart review to make sure that we didn't miss any adverse events. And then we had to do some normalization with endpoint data because pacemakers have a wide variety of programming parameters that we had to make sure were standardized. The devices that were being implanted were collected with extremely detailed measurement. In the paper, it describes the various measurements that they used to bring confidence to the location and the performance of the pacing lead in that place. But that led us, that supported the reliability of the data. And then part of the methodological considerations that I would submit is that they included this intensive chart review, but our pre-specified performance goals. So before we ever started, we said we're going to have basically lead complications, free of lead complications of at least 90% for us to consider this effective, to consider this good. And we were around 96%. So 2 examples of how Boston Scientific has used real-world evidence to support our product development. And the last example, we also have used it to inform how we're looking at future product development and for pacing and defibrillation. I'd like to talk real briefly about advancing real-world evidence globally. And one, there are multiple stakeholders, and we all have roles. But really, one of the most important stakeholders are regulatory agencies. Regulatory agencies not only provide guidance to how we operate, but they also are critical in public forums just like this. So I want to thank you. I want to thank ANVISA and ABRAIDI for bringing this together in a forum for all of us to share ideas and have these conversations. I also want to recognize ANVISA and the work that's done. I was sitting in the audience yesterday, and we were talking about the challenges of headcount. And Mariana, I'm listening to the translators. Thank you very much. You have dramatically improved my experience. My Portuguese is non-existent. And I thought I misunderstood because I thought they said that Mariana was effectively on her own. And so afterwards I asked Deborah, I said, I don't think I understood this correctly. How many people work in the medical device clinical review section? And she said, well, that'd be Mariana. And I was like, no, but who works with her? And she's like, no, she's alone. I can't imagine. You do great work. Hang in there. Thank you, and thank you. So these collaborations are tremendously important because it also helps to inform and to bring information back to regulatory agencies. And that's our role in industry. There are a variety of collaborative communities. One of the most important is IMDRF, the International Medical Device Regulators Forum. This brings concepts and regulatory guidance into harmonization globally. And thank you, ANVISA, for being a part of that, and thank you for leading where you do. IDERA is a European collaboration that works on real-world evidence policy, both for regulatory purposes as well as health economics. In the US, there's a collaboration called the Medical Device Innovation Consortium. This is a collaboration between medical device companies in the United States, the FDA, and to work on regulatory problems within the FDA, but we also interact with other agencies occasionally. The important thing about MDIC for us in the context of real-world evidence is a sub-organization called NEST, which is the National Evaluation Testing Center. And NEST has recently published 2 draft documents on real-world evidence quality and methodology. These documents are going to be foundational for us in the healthcare ecosystem as we consider real-world evidence quality and the process, kind of a standardized template for reporting. And then MD-EpiNet is another collaborative, the Medical Device Epidemiological Network, that's also done a significant amount of work with real-world evidence and supports real-world evidence in regulatory science. And then lastly, trade associations like ABRAIDI around the world and professional societies also have a role. There are example documents that have been published that support these collaborations. One of the documents I'd bring to your attention was an examples of FDA published 95 examples of real-world evidence that were used to support medical device approvals. IDERA recently reported or published a report on policy and strategy around the reuse of health data. And IMDRF has published methodological principles and data publications there as well. When I was doing a little bit of research for this paper, I really wanted to talk about the availability of data. And that was part of the comment I made earlier about healthcare data growing at 35%. I ran across this statistic, and I kind of shuddered a little bit. There are more mobile phones on the planet than there are people. I would love to do a quick survey, but I've only got 5 minutes and 42 seconds left. This is staggering. There are over 1 billion smartphones. 1 billion smartphones. These platforms lead us and present us with an opportunity for data collection that is, I don't know, there's no description strong enough for me to offer what that opportunity looks like. It gives us an opportunity to collect healthcare trends in a decentralized fashion, meaning we don't have to bring people into the hospital, into the office. We have 1 billion people with smartphones. This allows for rapid adoption of connected technology if we can do this effectively and safely. The increase in processing power and sensor innovation, we have smartwatches that can detect atrial fibrillation reliably. They're going to start collecting pulse oximetry data. Our smartphones and all of the technologies that we can leverage, and these are penetrated into the population. We also have a setting of evolving regulatory science, and that's where we come in, and that's where these global collaborations come in. is our ability to affect positive change and to really improve kind of the human condition and population health with the 9 billion people that are, 8 billion that are on the planet, but in 15 years, our population is probably going to be over 9.5 billion. So the future of real-world evidence. We have the capacity to transform patient outcomes. It's that simple. We can drive innovation, support faster regulatory approvals, bring products to patients faster. This enhances decision-making, empowers healthcare providers, payers, manufacturers, and again, the data are there. Data are available. We have a lot of challenges to overcome. This isn't going to be easy, but we certainly have more strength in collaboration with stakeholders as we address the quality, the integration, standardization issues. And there's unbelievable potential. There will always be a place for randomized controlled trials in our clinical evidence strategy. There are questions that cannot be effectively answered otherwise. But we have to leverage the opportunity that real-world evidence provides us and take advantage of being as creative as we can. When we think about regulatory science and the expectations we have for real-world evidence, we got to think about data relevance and reliability. Are the data fit for purpose? And we have to be rigorously disciplined in ensuring that we adhere to policies that make the data relevant, reliable, and fit for purpose. Are the data transparent? Do we have clear methodology and replication? This comes back to the pre-specification. We have to make decisions. We have to be transparent up front how we're going to analyze data. We have to have perspective and observational studies and study design. And we may even lead to some pragmatic trials. That's another talk for another day, unless you want to stay till 6. And then, that was a joke. And we have to continue to evolve our analytical methods. Statistics and the science of statistics continues to evolve and improve. So we have new testing, propensity score matching, and advanced causal inference analyses that give us more confidence in the analysis that we're performing and the conclusions that we're drawing. And so as I finish, it's kind of summaries and takeaways. Real-world evidence can accelerate and enhance the regulatory decision-making. All of the frameworks of regulatory frameworks are maturing. They continue to evolve. We're not done yet. If you go to the ISPOR meeting in September and you go to that debate, hopefully you agree that we're not done with guidance documents yet. This does require rigorous design and transparent execution to be fit for purpose. Real-world evidence enables longitudinal product lifecycle management, and public-private partnerships, just like this, are tremendous catalysts for moving this science forward and advancing our ability to impact population health through real-world evidence. So thank you very much, ANVISA and ABRAIDI, Dr. Sergio, Dr. Karen, Obrigado? Yes? Muti obrigado. Thank you very, very much. Oh, one more shout out again to the translators. Thank you, thank you, thank you. I really appreciate the work that you've done. Your voice in my ear has been fantastic. Thank you.
Alô, Dr. Dan.
Dr. Dan, thank you so
Eu vou pedir desculpas.
Thank you so much. I will excuse myself. I'll have to leave due to my flight, but I've just routed my questions to Dr. Sergio. He will move forward with the presentation. Thank you so much.
Thank you. Thank you.
Bom, marmitão.
So, it's on me now. I was not prepared for this gift that Karen gave to me. As a honorary regulatory person, I will complain to ANVISA. I will make a complaint, formal complaint. But one fantastic thing that I just found out is that the perspective of some people, when I say some people, there's an arrow in my head pointed to me. Sometimes there's this fantasy of real world data is all over. We don't need to do anything. Everything is valid. You just need to take a look to the populational numbers and it will solve the issue. When Dan started, he said, we've been doing this for a while now. And it comes to my mind the time when I started in something called Sanitary Surveillance Secretariat, a regulatory body that existed before ANVISA. It was from the Ministry of Health. This superintendents dealing with sanitary matters of health products. And then ANVISA was created in a law procedure in late 1999, and it was published, the law was published in 2000, right? And I was there working with the issues, with health products, and then I evolved from health products, and then I started to work with medical devices. If I had this view back there, medical devices, everything is related. But at that time, it was health products that I was working on. And for my surprise, is when I left the agency and I was working in an organization where the approved project registered number 1 in that organization was a knee implant. And I said, that's so nice. And I have signed the register process. And I was scared because the process was not, it was as a, it's like a product catalog. It's so big, centered in use instructions mainly. And then I calmed myself. I thought that maybe I will use this word. I was not screwed by the teams I was leading at first. Because in the end of the day, it was an expert doctor from this place here, the Hospital das Clínicas, that had analyzed the product and approved the product at that point. And at that point, there were no essential requirements, safety, efficacy, RDC, the regulation 185 here in Brazil. There's nothing. There was nothing. I thought it was based on a mild wind, but no, it was a product that was all over the world for years now. And we didn't have the technology and infrastructure to analyze that, and it was approved. It was not something that would cause any populational destruction in the countries where it was used, and no problem was caused here also. But the doctor that decided to suggest to the sanitary entity that he did that in a certain way, looking to real world data in a non-systematic way. It was a surgeon, and he said, it is used in the US, I've been there for 6 months, it's working, so let's approve it. And then I was the one that had to sign it. I signed a lot of things, and then I signed this one too. So now, listening to what are real world data, I'm calmed because of the things I did 20 years ago. But I have so much satisfaction now. I see this concept evolved a lot. And then always mentioned and valued the huge effort the product developers have to put a peacemaker in the chest of a patient, like you said, like you showed here. So I'm glad, I'm happy, because this, in fact, is self-criticism on a process. The self-criticism is not back in time. We are taking on everything we did right today, and it's adding another perspective, a new one. So I'm really happy because I'm hearing now this set of concepts that Dan presented so well here to us in a way that I understood everything, even me. And I'm glad that this will be useful. Karen laughed. She left things here in my hand, but I'm sure she is impacted with what she heard. And from now on, we'll have another resource in the mind of sanitary authorities when they are analyzing products. So thank you so much.
Now, last night, Karen sent me, we had a discussion on WhatsApp, and she sent me 3 questions, but I don't think I'm going to read them because many of the things that were in these questions Dan has already answered to exhaustion and in greater detail than what we have in the questions. So if I read them, I believe we'll all feel a little bit silly, especially me who will be reading them. So one thing that I wanted to ask Dan myself, and again, this comes from the little knowledge that I have, and like everyone mentioned before, Washam, Dan, and other speakers, this is not ABRAIDI's opinion. I'm speaking for myself here. So the question is, to what extent, Dan, do governance issues interfere in this process of using real-world evidence? And I ask this for a reason. If the product development department from a certain organization, which certainly has commitments and this mindset focused on a certain pathway. But at the same time, in the world, we have regulatory authorities that you included in your presentation, of course. But we have a number of different perspectives coming from other stakeholders that maybe might be part of this puzzle of real-world evidence. So to what extent do we have this participation? How much can it interfere in the decision-making process to determine this is what real-world evidence is? Let's move on with it.
A very, very good question and very applicable. Governance when you are talking about real-world evidence has two connotations, two applications. There's the regulatory governance, so regulation and guidance that influence how the reviewers review data. And then there's data governance. Data governance refers to how the data are collected, how they're analyzed, and there are regulations, guidances, not regulations, they're guidances related to data governance, but there are a lot of white papers and a lot of ideas about data governance. So, regulatory governance. It is fascinating to me that in large regulatory agencies or in geographies where there may be multiple regulatory agencies that contribute to oversight of medical products that are under the same guidance documents, they are interpreted differently. And in some cases, it really comes down to an individual reviewer's perspective on the interpretation of the policy. And that is an opportunity for us. That's not, when we receive feedback from regulators that's either unexpected or surprising, that's an opportunity for education for us. And it also tells us that we probably need to look at our assumptions a little bit differently. Harmonizing the process, harmonizing the governance, regulatory governance would be tremendously valuable. The step, the implementation of that is the challenge. And that's where we need to come together across the entire ecosystem to have a uniform perspective on how these guidances and how the governance are interpreted and applied. And that's education. It's environments just like this. The data governance is aligning and coalescing into a uniform standard. And that's happening because it becomes simpler for data interaction if we have uniform standards for data governance. And so that's kind of beyond, if I start talking about that, you're gonna give me the 8 count, okay? And so the data governance is starting to become more consistent and more aligned, but it still has a ways to go. And so both are opportunities for us to spend some time and effort on. For the regulators and for the governance as applied to the review process is education. That's, I think, is the answer.
That was an excellent answer, by the way. And I believe that events like these, especially this one, can be an opportunity for fostering this education that needs to be based in a trusting process. In Brazil, we often use the term reliance in English for the search of results, but it's about trust. It's about building this for the long term. And in the end, this is what we did in this meeting, bringing experts such as Dan and experts like all of the speakers who talked to us, who were able to demonstrate to the regulatory authority their transparency, their purpose, and how serious they are in this field, so we can build trust to perhaps accept proposals and perhaps review decisions. So this is combined to the educational process that you just brought up. And again, we need this education and we need to learn how to trust each other. That's what I'm trying to say. I think that we now sort of by accident conclude this event because this presentation was supposed to happen at a different time. We need to make some changes to accommodate different needs. But I believe that it was a very happy ending. We had Dan to close our session on a high note. This was certainly a great opportunity for the regulatory community in Brazil. And it's a shame, but I think people will be listening to this later. It's a shame we don't have more people here listening this presentation and feeling what I am feeling right now. Thank you so much.
Obrigado. Good. Thank you.
Bom,
So this is the end of our seminar. Of course, I have to say thank you to the interpreters, to the technical team, the whole ABRAIDI team, my colleagues working in regulatory affairs, all the speakers who kindly accepted to travel maybe 10, 12 hours to be here and accepted to face the reality in Brazil. Brazil is in the media right now for different reasons, but we believe in our country and we're trying to build it and make it better. Thank you so much.